I do hope that we are soon ready to start with our conference. Peter braucht noch ein bisschen. Okay. Guten Morgen, meine Damen und Herren. Muy buenos días, estimados señoras y señores. Good morning, ladies and gentlemen. I'm happy to open the sessions of today. You remember yesterday was a very fruitful day, a very good opening of the soil classification conference. And we would like to continue today the same way. And I would like to introduce the first keynote already. This is Curtis Monger, and you know him. He is a very exposed soil scientist, very successful in soil classification, soil genesis, and he will give us a talk on soil taxonomy and the philosophy of Julius Stuart Mill. So I will go down, but the floor is yours, Curtis.
Okay, thank you, Carl. And I want to be sure the microphone is working. I think it is. This one's working okay. Good morning, everyone. I'm very glad to be here, and I wanted to just say a few words about when I was a professor till 2015. I worked with many of you, and I got to know many of you during that period. And then I took a job with the U.S. Department of Agriculture as the National Leader of Soil Survey Standards from 2015 to last year, 2021. And the reason I bring that up is because that is when I became interested in the philosophy of John Stuart Mill and how John Stuart Mill's thinking is in taxonomy. It's fundamental for soil taxonomy, and that's what I want to talk about. And I retired from the USDA August 28th of last year, and now I'm back at New Mexico State as Professor Emeritus. Great job. I help teach some, but I have graduate students write grant proposals and attend conferences like this. So, okay, so the talk is about John Stuart Mill and soil taxonomy. And who was John Stuart Mill? Well, he was an English philosopher, a political economist, member of parliament, civil servant. But if you read his writings, he was a very early advocate of women's rights during that time period. And most of his philosophy that's in taxonomy came from this book, A System of Logic. And it's a very thick book where he basically articulates many things. Classification is one, but he builds on the work of Francis Bacon, the experimental method, multiple working hypotheses to drive at scientific conclusions. So I wanted to start out with this question, or statement rather. And when I was in the position with the USDA, my department oversaw the technical documents, which included soil taxonomy. And we would get lots of questions from people in the field mapping soils about, does this meet, for example, the criteria for a cambic horizon? Said, well, we're not really sure, but we'll check on it. And the way that we would check on it is we would typically start with the keys. And many times the answer was in the keys, the most recent keys. You just had to read a little further or reread some of the definitions or go to somewhere else in the keys to find the answer to the question. But many times we don't know the answer to that question. So this is the procedure typically that we would go through to try to find the answer. Is we would go through the second edition, this purple or mauve color soil taxonomy that's published in 1999. And there's a lot more material in there, a lot of explanation about all the different taxa. If we didn't find it there, we'd go back to this green book, the 1975. If it wasn't there, we'd go to the seventh approximation that was published in 1960. And if it wasn't there, we'd go to the Guy Smith interviews and see if we could find the answer in the Guy Smith interview. So let me walk through these, starting with the Soil Taxonomy, second edition, 1999. So this is still the authoritative reference for soil taxonomy as used, except for a few taxa that now exist in the keys that didn't exist back in 1999. And it's available PDF online. So if you ever have any questions about, for example, the subgroups, where do they occur? On what landforms do they occur? Are there any special characteristics that need to go into an explanation? All of that is laid out in the second edition. And taxonomy was built by Guy Smith. He was the leader, but many people, and it was an international system where pedologists around the world contributed to this. It was a matter of getting that understanding of international pedologic intellect and trying to put it into taxonomy. And there were international committees that were set up, and they studied, for example, when I was a graduate student, there was the ICOMID, the International Committee on Aerosols, and a group of people from all over the arid regions of the world worked their way across and discussed and argued, debated. And all of those international committee reports, the findings are in this 1999 edition. But no mention of John Stuart Mill. So I don't know if it was space limitations. It was already a thick book, and the group that was putting it together, this is after Guy Smith, said there just isn't room for philosophy on classification here. But anyway, it doesn't make it to the 1999 version. But if you go back to the 1975, there's a lot of philosophy and a lot of rationale in the 75, and there's some direct quotations. I'm going to dissect those with you, and more discussion of the classification. And Marlon Klein, he was a professor at Cornell University, and he was very much instrumental working with Guy Smith to put this material together. I'll magnify these in just a minute just to show you, some of the quotations. John Stuart Mill said, and John Stuart Mill pointed out. That's the type of philosophy that made it into taxonomy that's in the 75. And then these are really good papers for understanding the development of taxonomy philosophically. Klein 49 and Klein 1963. Okay, so we didn't find the answer in the 1975, so we go on to the seventh approximation. And again, there's one direct quote, John Stuart Mill, reference Marlon Klein. But this is a really interesting book for teaching. And there's all this science in there. There's all these thin sections in there, and rationale in the seventh approximation that again got cut out in later issues, and even more discussion of philosophy of classification than in the 75. And I'm just going to pull out one page and enlarge it and see if hopefully that's large enough that you can make it out. But they have statements like classifications are contrivances, and that they're not truths in themselves that are discoverable. So, for example, the Earth isn't a sphere. Isn't flat, it's a sphere, and it's a sphere not in the center of the universe, but it is going around a local star in a galaxy, among many galaxies. Classification doesn't have those discoverable truths. Like when you burn something, it releases phlogiston, as what was thought at one time. No, it's all based on the purpose of the class. What's the classification made for? And for example, when I taught soil classification, the students, first day of class, they'd come in and you could say, okay, all the students that have a hat on over here, all the students that don't have a hat over here. And you've just made a classification based on whether or not people have hats on. So class is all about what's the purpose that you're trying to get to. And also that as we learn more, classification is going to evolve. And it should evolve. It should not be stagnant, but it should be a very dynamic system. So let's say we didn't find it there, so we go to the Guy Smith interviews, and I think the core idea is that the best taxonomy is the one that permits the greatest number of most important statements. And this might get back to the Babel concept that Erica talked about yesterday. I'm not sure. It'd be interesting to have that conversation with us. And the other important idea that Guy Smith writes about in the interviews is both John Stuart Mill and Bridgman had a very large effect on me. Now, Bridgman, he had written a book called The Logic of Modern Physics, and this was in 1934, but it was about operational definitions, and we've encountered that many times during our field trip, our field excursion, and that is, okay, on what method do you base percent clay? On what method do you base electrical conductivity? On what method do you base? And it's very important to specify the methodology of how the ideas are being quantified. And so that was Bridgman. And so Guy Smith, the other thing was, it's got to be quantitative. And a lot of these definitions are really tough because they're so darn quantitative. But everything has to be defined numerically, even color, 10 wire, 4-2. But he goes on to say that Bridgman and John Stuart Mill, that he had read many books, but he bought those two books for his own library. He said they had an enormous impact on me in the development of soil taxonomy. So let me go to the first quotation. Here it is magnified, and I just want to dissect it and some of the important ideas. But a good taxonomy is one that can be remembrance that you can carry with you in your head when you go to the field. And so the Greek and Latin root words. A lot of people that are not familiar with taxonomy and they see this name, right away they're turned off. It's like, what is this? And you say, give me 3 minutes, just 3 minutes to let you know that these are words that are in the language, generally speaking, that many people are already familiar with. And it's a matter of taking these symbols and starting from the right, working to the left, like Hebrew or Arabic, and you basically just build that name from right to left. And once you show them that, and once you show them the, you know, the root words, I think they get it. They get it right away. But the point is, it's something easily remembered. That was the first point from that paragraph. Then the other principle was, okay, classification is all about, you've got a bunch of objects and you put them into groups, okay? This is saying, put them into groups in which there can be derived the greatest number of propositions. What does that mean? Well, this is my interpretation. For example, we have soil moisture regimes that come in high in taxonomy, and there are many propositions that can be inferred from those with respect to number one, use and management, number two, genesis and profile properties. But take the aquatic moisture regime, for example. To know that a soil has an aquatic moisture regime, you can infer right away that from an agricultural standpoint, yes, there are some crops that might be grown, but many crops cannot be grown. Same's true with forestry, same's true with engineering, aquatic moisture regime, no septic tanks, you're going to have a lot of problems. So that would go up high as something that many propositions can be derived from. Next, genesis, aquatic moisture regime. Well, right away we can infer things about redoxymorphic, you know, clay, organic carbon. On the other end, the aeritic moisture regime, in terms of genesis, well, secondary carbonates, salts, items that properties you wouldn't find in more humid regions. Okay, so put that high in the taxonomy. Moving down, that he makes the statement that most often what is obvious is not the best property. It's not the most important property, that unobvious. For example, if we go back to Curtis Marbett's classification, and like right now, if you look at soils in New Mexico, this publication needs to be updated, but they're based on color. The color is the highest category. So if you look at brown soils, okay, what do brown soils tell you? What do gray soils tell you? Well, there are some inferences you can make from those. But if you compare brown soil, and if that brown soil is an Ustauf, right away, an alpha soil, we have O horizons that come to mind. We have E horizons. We have BTs. Of course, a lot of that's plowed, and those are gone. And the argillic is now at the surface. But a lot of information, and this one being in a semi-arid moisture regime. Okay. Then working your way down to the end of this paragraph, what is meant by importance? And that's where it differs. And the example Erica showed yesterday about the Russian, the WRB, the taxonomy with respect to cryosols or gelisols, and just the differences, but importance. And again, important for what? Important, what does that mean? Consequential. Consequential for what? What do you want it to be? Does it need to have practical ends? Is that what it is? Or are you like a botanist and you just want to know what's out there in nature? But what is the end? Okay, very important in terms of the structure. Then if we move to the other quotation, I wanted to magnify for you. And this is all about one thing, and that's Genesis. And what he's talking about here is should be possible from which many causes. What is the cause? What is the mechanism? Cause and effect from which other properties are derived. And it comes down that unfortunately, seldom can you base a classification system on causes, on not the properties, but the processes, the mechanisms. And I know Spinoza, talked about that too, about the begetting and the begotten, that like in when Darwin, I'll go off on a tangent just a bit, but natural selection, and the diversification of different, just the biodiversity, that there's a lot of processes that result in results. Even geology, the mountains that we've seen, those are the results of processes. But we don't classify the processes, the mechanism. We classify the result, what's left. And that's what he's getting at there. And this was mentioned earlier about the World Congress in Madison in 1960. And back in those days, they transcribed everything that was spoken, pretty much. And it's really quite the record. But here's an exchange between Charles Darwin and Cuvier, and they're talking this subject about genesis versus properties. And Cuvier brings up the point that soil genesis deals with the explanations of how a soil or the entity came to be formed, and that we don't classify these properties. And Charles Kellogg agrees with him, and I think emphasizes it, that yes, we do not classify the causation, but we do classify the properties. And that last statement there, we use genesis, but it is one step removed from the classification itself. And this is so easy to observe. And I think I would dare say every excursion I've ever been on dealing with soil classification, that genesis is such a major part of those discussions. And like, I think all of our sites that we saw on the field excursion, but this, are there lithologic discontinuities in that profile? That was quite the discussion, quite the great discussion, quite the necessary discussion. And that's what people like to talk about. But again, the point is that we're not classifying the mechanisms, the processes. We're classifying the properties that result from those. That's the point that I'm trying to get across here. And to bring it a little bit more in terms of emphasis, here's a great paper. It goes back to 1963, Threads of Genesis in the Seventh Approximation. And the author, Arvard Klein, goes through and basically is saying that pick any one of, at that time, the orders. They're based on diagnostic horizons, and those diagnostic horizons are all about genesis. And even the Internacionals, there is no genesis. That's right. So the Internacionals were, to preserve the azonal soil concept, there's no petagenesis. And so therefore it's based on genesis or lack thereof. One other example, Roy Simonson. In this paper, is going back looking at the evolution of soil survey and soil mapping and classification in the United States. And he talks about going back to the early days of Whitney. And he's saying, this is, I think, quite the interesting statement, but back in those days, that people would look at the bottom of the cut, not the top of the cut. So if there's a road cut, and there's a lot of road construction back in those days, so they were looking at the sea horizon. And the sea horizon, is it loess? Is it alluvium? Is it glacial till? Is it limestone residuum? That's what they were after, and add a little texture to that. So this is Whitney's map that came up, and it's pretty much a parent material map. So the yellow in the southeast, that's the coastal plain. You can see all the, what we would now call the fluvents along the rivers. The green in the upper Midwest, that's the continental glaciation boundary. That orange, those are the big pluvial glacial lakes. The light blue is the limestone residuum. And that was soil until Curtis Marbeth discovered Dokuchaev and Dokuchaev's students. And so Curtis Marbeth, the Russian thought had been already translated into German. So Curtis Marbeth taught himself German so that he could translate Glinka's work, because Glinka had it, that really summarized the Russian thought. It's already in German. Curtis Marbeth teaches himself German and then translates that into English. And at that point, this map changes to that. So every one of these we still have with us a little bit today in some form. So in the southeast, that pink, those were what we call the ultrasols. Back in those days, these were podzolic. They weren't podzels. The podzels are the blue up high. Those are what we now call the spotosols, or the podzol. But the pink, those were podzolic in the sense that you had the O, you had the A, you had the E, you had material being carried down vertically in the profile. And these were the podzolic red and yellow soils. Above that, the yellow, those were the podzolic gray and brown soils. Now we call them alpha sols. And then you get into the Midwest, the phaeozyms, those tall grass prairie soils, thick mollichypedons, but no calcium carbonate, not much, until you keep going west and you cross into the Chernozyms and keep going west into the Caseozyms. Maybe mispronouncing that. And of course now in taxonomy, they subdivide that into like the mollisols, the humid ones, the udols, and then the ustols. But anyway, that's it. That's a Genesis map that came about from Curtis Marbeth discovering the ideas of the Russians by way of the Germans. So I would say if Arvard Klein were here, I would say this paper isn't strong enough. Instead of threads, support cables. That everything in taxonomy pretty much is related to Genesis. So kind of a summary of that is, okay, Genesis, you can understand the accessory properties is arid, okay, you make inferences about carbonates and so forth. But the big thing in terms of mapping is the accuracy of the map. And so if you go out and drill holes in the landscape and try to connect the dots, yeah, you can make a soil map. In some cases, it might be a pretty good soil map. But if you really understand the genesis of that landscape, you understand where those young sediments are, you understand where those old geomorphic surfaces are, where you've got petagenesis occurring for a long time, you get strong argillic horizons or strong petrocalcic horizons. If you really understand that genesis, then you can make some accurate maps. I remember my brother-in-law, he's a civil engineer. One time he said, we use soil maps all the time. He said, how do you guys know what's down there? And, I didn't give him a good explanation, but that's it. A really good map is somebody who really understands the genesis of that landscape. And just an example, you can take any block diagram. I'll put it in here. I like this block diagram. It's showing this ancient mid-Pleistocene geomorphic surface in the desert north of here. And got a petrocalcic horizon that's formed, but that is so old that it's gone through many glacial fluvial periods. It's gone through at least 8 glacial interglacial cycles. And during the wetter glacial cycles, that's when the lakes around here fill up with water and you still see the shorelines. But basically, that's when that petrocalcic horizon becomes karst topography. And now you get, sinkholes in the petrocalcic horizon. And then you shift back to an arid period, and now the depth of wetting shifts up, and you form carbonate over those sinkhole material. But just an example of how understanding the landscape, and then understanding that, okay, we've got these soil individuals or polypedons, and we try to get a representative lab sampling of those so that we can really understand. And then the last point is his second book, and this is more all about human nature. And in here he talks about two things that really are pertinent. And a group of individuals, whether it's scientists or name the group, but in our case, we got a group of scientists, pedologists, soil taxonomists, and you can just see it in this conference that individuals pursuing their own interests, whether it's artisols or what, really contributes. It really enriches. And the point that he makes is it's a really good thing for individuals to pursue their own interests, their own good, as long as it doesn't interfere or deprive others. And you can see it, for example, in our case, in the U.S., the soil moisture regime's high. You got folks in the East, and it's all Utic, and they think it's wasted space. But the people in the West say, no, it explains the forest boundary and the grassland boundary, and it explains as you go through the mollisols into the back into the alpha soils and the high. And but that would be one example. And in the National Cooperative Soil Survey, it's all about getting a whole bunch of people to try to agree nationally, and we don't have the international component that we did have at one time, which is very unfortunate, to try to come to some consensus that, yeah, definitely subaqueous soils, bueno, go for it, is good, but don't put the aquisalids in it, for example. And then, but the other point that he makes is any type of documentation really does need to be challenged. And it's a great thing to have fundamental challenges because it gives you an opportunity to defend the system as it exists, but also it prevents dogma. So absolutely, bring it up, question it, debate it, and then go with the idea. If it's a good idea, it may be a great idea. To make a big change, it could be a great idea. So that's John Stuart Mill. That's ways that he contributed to soil taxonomy, and that I thank you. And there's my email, by the way, if anyone needs it, to carry on conversations or future collaborations or so forth. So thank you.
Thank you a lot, Curtis. You brought us to the roots back and the philosophy behind it. And often when we discuss things, we only see the actual purposes of our doing, but not the whole frame. So we have a lot of time. You did not use all your time. So we have a lot of time for discussions. And I invite all of you to put questions to Curtis Monger. Who is willing? Okay, come ahead.
Professor Monger, thank you very much for your conference. I didn't know who was John Stuart Mill. I wrote a little book about the different soil classification school, Russian, Soviet Russian school, European school, and North American school. I will include in the future this idea from John Stuart Mill. Thank you very much.
Good. Great. Okay, thank you.
You have to, you want to answer it?
Well, that was a comment. I think.
It was a comment, it's
Yeah.
clear.
Oh,
yeah.
that my comment to his comment? Fantastic. Thank you.
Thank you.
I think it's a great idea. Yes. Yeah.
Okay, go ahead, please.
Curtis, I also thank you a lot for this talk, which brings us to the basic principles from which we are very often isolated or at least distant in our everyday practical research. I have a question which I have since many years to soil taxonomy, and maybe now this is the moment to direct it to you as the representative of this great classification. I understood now from your talk this approach of application of general propositions to grouping of objects into some groups or units. What I am always be a little bit worried is the number of these propositions. What do I mean? Let's go to the top level of soil taxonomy. Molysols, alphisols, spodosols, defined according to certain substantial characteristics related to genesis. Aridisols, climate and soil moisture regime, absolutely different general proposition. Antisols, no substantial characteristics, no climate, but the grade of evolution, primitive soils, evolutionary proposition. We are somehow accustomed to basic classification principle related to biological, botanic classification of Linnaeus. One principle for one taxonomic level. For example, type of flower and fruit. There is no situation in botanic classification when one plants are classified according to their type of flower and the other plants according to their, for example, growing in the humid tropical or arid climate. So I don't think that this is a question, maybe it's more a comment, but do you think that this general proposition in the classification should be uniform or at least limited for certain taxonomic level, or such diversity as suggested by soil taxonomy is possible and have future? I'm not sure that my question is really clear, but I tried to express it as clear as it's possible for me.
Okay. And
Thank you, Sergey. I think this is a comment which can be commented.
okay, right, yeah. And your comment was very good too. Thank you. So classes. We're talking about putting objects into classes. So let's back all the way up to particle size, sand, silt, and clay. I mean, there's a continuum in sizes there, but we make boundaries. We put them into classes. That is one class. And then those in turn get scaled up and grouped into more and more classes. So for example, we say a molecule we're talking about more than organic carbon. Organic carbon is a very important part of molecular, but a molecular or horizon is a synthesis of many properties. And then we come up with this idea in our minds or contrivance about entities on the landscape. And we all know soils differ across the landscape. But a three-dimensional entity on the landscape. So it's easy to imagine a lake, you know, is very uniform, you know, in its makeup, material makeup, and its mass, its matter. And it has three dimensions, you know, 2 dimensions on the surface and a third dimension. Soils do too. Soils have these 3 dimensions. And that's the other idea, and it's brought up a couple of times, but the soil body. We've got conceptually soil bodies on the landscape composed of many different properties, a synthesis of properties. And another thing that Roy Simonson said in that paper that I showed is, he said the most important thing we learned from the first 50 years of mapping soils in the United States is that a soil series is based up of many properties uniquely combined. So for example, I could tell you about, I grew up on the Fullerton series, and no one would know what that is, but if someone did know what it is, they would understand that it's many, many properties. It was, you know, the O and the A and the E and a huge thick, I mean, we're talking 30-meter thick argillic horizon with such a little bitty alluvial horizon. And that we talked about that a lot, about mass balance. There's no way that alluvial horizon could, in some of these cases, account for all of that clay. But it's a synthesis of properties that would come up with these conceptual boundaries for bodies on the landscape. So what's out there in nature? But again, going back to the early days when they were making soil maps, the Congress and other people who are developing policy said, oh, those are pretty maps, but what good are they? So that's where you bring in the utilitarian purpose is, you know, who cares about the, yeah, the scientists care about them, and, you know, like the botanists care about biodiversity and so forth, but of what good are they to society? So we not only have the scientific aspect of what's out there in nature, but utilitarian, what's it good for humanity? I think, and that's where a lot of the definitions, you know, were broken, you know, were derived. So, yeah, Sergey, that's my comment to your comment. Is that even close to what you were getting at?
Maybe I am allowed to make a comment on the comment.
Okay, go ahead.
Yes. So, if I understand right, Curtis, the utilitarian principle make the classification and maps of soils useful for the broadest community possible is the main purpose. And for this purpose, you could sacrifice uniformity of basic principles, of definition of groups, just to make it more useful. It is more important that this soil is has acidic soil moisture regime than all other characteristics. So we define this group according to its regime. And for healthy soils is most important, again, for practical use of broadest community, that it has thick clay alluvial horizon, and we defined it according to this very different principle from arid soils. Is this right?
That is right. Yep. Yep.
Now I got it. Thank you.
Yeah. And just to add to that real quick, so the acidic moisture regime, the boundary was the sown, you know, what could be sown versus the unsown. Yeah, you might sow it, but it's not going to grow without irrigation. And so that was very much a utilitarian boundary. And it coincides, like we said, with a lot of, you know, properties in the profile. But that was an example of an agricultural bias boundary. Yeah.
This is something very different from Linnell's and classic classifications of the 18th century.
Yeah. Okay. Good. Okay. I'm sorry. Yeah.
May I put a question in between, a short one? You mentioned soils are three-dimensional. Now, for me, it's very important that all soils are four-dimensional, not only three-dimensional. And my question would be, is this, can this be taken from soil classification or soil taxonomy, that they really take into account that soils are four-dimensional?
The Paley Great Group's attempts to do that. The idea, okay, there's a soil in the landscape that has a long memory. What is evidence of that long memory? And that would be an abrupt clay content that doesn't decrease with it. It's not stratigraphic, it's pedogenic, and it would have taken, for this particular soil, many millennia to develop such a strong profile. That's one example where the fourth dimension could be derived. Yeah.
Ben, you?
Yeah, Curtis, this last week at a soil pit, when Erica was the pit manager, she asked for the genetic horizons to be described, identified and described. But another conclusion that I made was that we were never really sure about Genesis. Talking about Genesis opened up such a lot of questions, especially as newcomers to a particular soil pit. So it seems a contradiction then to persist with the idea of genetic horizons as opposed to simply morphological horizons. Sure, Genesis is important when you're working in a landscape and you need to understand the geomorphology and how the landscape is derived, but simply purely for a soil profile, I guess in Australia we've tended to go to the more purely morphological approach as opposed to a genetic approach. So just maybe a comment on that, please.
Yeah. So for a specific profile, typically it does take a detailed study with multiple hypotheses about how this soil from a Genesis standpoint could have resulted, and just trying to eliminate those, okay? And so it's a much longer, more detailed study. But in general principles, to have a clay enrichment with argillans is fairly solid evidence that there is vertical migration of platy clay particles. And then you couple that with thin section, we got the argillans, you know, where the clays are lying tangential, parallel to the surface. Oxasols, being able to trace something laterally, you know, the same parent material from a, say, a temperate zone into a tropical zone, and just watching how the weatheral minerals disappear, and all that's left are the most insoluble minerals. And again, that's Genesis, that's morphology B lowercase o, but it's a general principle. It's just extremely highly weathered, and the mineralogy tells us that. So, yeah.
We have possibilities for more questions. Cesare, go up.
Return to philosophies, to the roots, and we can ask, for example, why soil taxonomy has not been fully accepted years ago as the only international system. Yes, probably, I know political various reasons, but in my opinion, breaking of the direct and visible relation to soil origin could be one of such reasons. Yes, because I think, in my opinion, as I can feel it, discussing with colleagues in various countries, it is large expectation that soil classification systems will clearly reflect the relationship to soil origin. And for example, in WRB, it is probably much better recognizable for people. And maybe this is why WRB for people also, thanks to names used for soil groups, is for at least for some people in some countries more acceptable. Because if we look to national classification, still this very close relation of classification to various concepts of soil origin or soil diversification, distribution is very, very strong. But absolutely, I agree that there are various users of classification. Yes, what is important? Just concentration of only on origin, or also on soil properties, services, because various users may also say taxonomy is not only for classification of objects, which we know, but classification should give us, especially maps, should give us additional knowledge, useful knowledge for farmers, various users. And there are really important question how to construct classifications in relation to which, how to say, paradigm. And what we can, for example, observe in WRB, that sometimes when we create diagnostic criteria for particular reference group, sometimes after some time, people report, based only on this diagnostic criteria, report their soils which have completely different origin and were developed in completely different environmental conditions as the soils originally, how to say, understood as the typical in this unit for whom the criteria was created. And if it is combined with traditional name of this soil unit, as we have, for example, castanozems, yes, it is clearly related to specific concept of soil origin and zonation. And if organically we have soils from another territories developed in another way, but they meet the criteria, what to do? This is important, how to say, trouble in this relation between, how to say, concept of classification. In this way, morphological classification, which breaks the direct relation to origin, works better. But if expectation is that it should be still kept. So thank you for, it is not a question, but I just wanted to say that the topics you showed us are really of primary importance for all people who discuss, who develop classification systems worldwide. Yes, so thank you for this review and remarks. Thank you.
Thank you. Yes. Yeah. Just, okay. We're okay. Two comments. Equifinality has been a word used to describe that you've got different processes that lead to the same result. And you can imagine that, again, to use tropical soils and oxisol, there might be some soils that on the fourth dimension get there by way of alpha sols, or by way of ultrasols, or by way of just intersols going, intersols having oxic sediments. And so it's a very quick path to there. So equifinality, definitely. But again, the genesis, the fact that you can trace their different origins, to get to the final product enhances understanding. And so when I was at New Mexico State the first time, my office neighbor was a hydrologist, an engineer. He didn't want to know anything about taxonomy. He wanted to know percent sand, silt, and clay, and just properties. That way he could plug them into his models. But that'd be an example of like, you could, for the continent of Africa, have a property map showing the percent sand in the upper 10 centimeters for the entire continent. And that's a lot of, But for people who even know a little bit of taxonomy, if you can say, here are the oxasols, that is a much deeper understanding of the soils of Africa, you know. And then the other thing is, taxonomy. It's good, in my opinion, that taxonomy isn't the classification system. I think that's a blessing, really. It's supplemental. It can help, but it's like buying local. You know, when you're local, it's more useful. I think, in my opinion, healthier, greater diversity to use the local classifications and other classifications. So.
Thanks. We have still time because not the next, but the third paper is missing. Therefore, we can use a little bit of time. Cesare, you allow me?
May I have additional question or comment?
Okay.
Because it is also very important question what you asked, time as the fourth dimension. And in soil classification, we should recognize two aspects of this question. First, normal development of soil from young soils to well-developed soils, or factors which rejuvenate soils. And I think this aspect is quite well recognized in soil classification, also in soil taxonomy. Beautiful distinction between anti-soils, inceptive soils, and other soils. But there is also another aspect, polygenesis of soils, yes, or variant soils. It is also a time-dependent process, and there is, I think, largest problem for classifications, how to include the paleosoils, yes, or polygenetic soils, how to apply the criteria which we developed for the first, order of soils, yes, to merge in classification all the aspects of the fourth dimensions you asked, yes. So for me, there are, as I told, two aspects. I think in soil taxonomy, it is also partly, both aspects are partly, a second aspect is partly developed also.
Yeah, good comment. With one question over here.
Okay, one more question here. I would like to allow myself also to put the last question then.
Professor Karlstar, can I?
Yeah. Yes.
Yeah? Okay. Okay, also comment. But at first, I think the presentation of Curtis is very great because stimulate us for the public conversation and exchange of ideas more than questions. I think what Czarek said before, that four-dimension time, it's also not so easy to put this aspect because some soils, for example, anti-soils in soil taxonomy, or some weakly developed soils in other classifications, not necessarily are dependent only on time. For example, in Arctic conditions, in high mountains, very weakly developed soils are the, we can say, climax soils. They cannot develop more because of conditions. So not only time, but sometimes conditions complicate this situation. And my personal feeling is that this problem that we still look at the soil, at the profile, by the visible features like soil horizons and so on, so genetic features, and we, in the same time, look for parameters which could be as much universal as possible and measurable, is the biggest problem of all the soil taxonomies, not only about soil taxonomy of USA, but also WRB and many national classifications. Because we, classifying different soils, we use different criteria, as Sergey said. And probably until we do it, and we will do it for sure, because it's very visible things, soil morphology is the first thing which we see. And this puts our mind into the direction in which we are thinking. But later we are looking for some parameters, chemical, physical, and so on, which not always are visible in the soil profile. Okay, thank you. It's just a comment.
Yeah. Yeah, I totally agree. That was a good comment. And it's interesting to think about different velocities of time that, yeah, a frozen soil or soil saturated with water versus a, say, loess, you know, with many weatherable minerals, and how rapidly through on that fourth dimension petagenesis does modify the soil. Yeah, so good.
Felicitaciones por su presentación, doctor Curtis. Nuestro grupo de trabajo está enfocado a la conservación de los suelos, en particular lo que nosotros lo denominamos la zona crítica. ¿Por qué? Porque consideramos desde el punto de vista generalmente de los hidroedafólogos que el suelo es la zona crítica.
Thank you very much for your presentation. Our group is working in the degradation of soils, particularly in the critic zone, because it is important by the point of view of the hydrological studies.
Y es el centro de la zona crítica. Y en ese sentido es muy importante poder comunicarnos dentro de nuestros objetivos de poder pues, contemplar de una manera muy exacta, como lo dice aquí, el hecho de que se enfrenten varios retos del funcionamiento de los suelos en relación con esta zona crítica que comprende los límites de la vegetación en la parte externa y el contacto con el manto freático en la parte interna.
And it is important to understand and to research this critical zone because it is the contact between the part of the vegetation and also the part of the hydrological resources.
Por lo tanto, pues tenemos que ser muy claros para comunicarnos con otras ciencias como es la física y las matemáticas. Entonces, mi pregunta es, ¿qué tantos avances existen en relación con objetivos puntuales que evidentemente son el tener certidumbre del comportamiento de la fase líquida, la fase gaseosa y la fase sólida del suelo?
And it is also important to integrate other disciplines like the physics, the maths, the modulation. So the question is, what are the advances of these integrating studies to the soil to understand the phase, the gas phase, the liquid phase, and the solid phase of the soil?
Mm-hmm.
That's my,
Yeah.
that must,
Yeah, that's the question, please.
esa es mi pregunta.
Yeah.
What are the advances of integrating other disciplines to understand all these phases, the liquid phases, the gas phases, the solid phases?
And I think within a soil science department, where you have the soil physicists, the soil chemists, the soil microbiologists and biologists, that the pedologists are the ones that integrate. I mean, the pedologists understand about available water holding capacity and the difference between volumetric water and pressure or tension to pull water off. They understand cation exchange capacity. They understand the importance of microbiological. So I think we pedologists, are at the center that synthesize a lot of disciplines.
Okay.
Well, okay, thank you.
Okay. Yeah. Okay.
Well, I would like to allow myself to put the last question. So we all agree that soils are formed through the influence of soil forming factors. The time was discussed, it is a parent material, it is the climate, it is the relief, are the biota. Increasing problems I have with men, because man behaved originally like a biota, and meanwhile man behaves like geology and changes soils in this way. Now, if we describe soils and classify soils, we are normally not able to fully show the influence of the soil forming factors, at least not directly. But the soil forming factors, they cause processes. And I think the processes are the most important things happening in the soils. However, still you see some things. We look to the clay cutants, and they are directly a result of a process. But many other things we observe in soils do not show us directly processes. And therefore, for soil description, and we need to use the properties. You mentioned this several times. We need the properties. However, for me, the properties are not sufficient. If you only use properties for describing and classifying soils, you cannot cover the whole what soils are. So therefore, we need some connections between properties and the processes. And is there a principle behind in taxonomy or so where you can say, yes, we use the processes, but in relation, the properties, but in relation to the processes active in the soils?
I totally agree that if you could synthesize the result versus the causation, that there is that connection there, and that connection can be very complex. Just to say, okay, we classify the results and we use the causation to explain it. Maybe we can do better. Maybe that's an opportunity for young pedologists, young scientists to take that on as a challenge to make that connection better. Yeah. Okay. Okay.
We have to close this part. But thank you very much for your nice presentation and also for the good discussion we had. So we made use of this contribution. Now we want to start with the first virtual part, and this is a presentation of Brecht Rams, Soil Catenas in the Age of Digital Soil Mapping, Insights from a Soil Survey in the Zambezi River Basin. So you'll find out if technically this is possible.
Hello, everyone. Can you hear me?
PhD reference, give us a moment. They are switching in the auditorium, so you are visiting right now online, but give us a moment, please.
Great, yeah.
We're already in the auditorium.
Okay, you are now be seen in the auditorium.
Okay, thank you. Good morning, everyone there. I am Brecht Boms, speaking here from Belgium. And as introduced already, I will be giving a small talk on our insights from a soil survey that we did in Zambia a while back, and how we integrated the concept of soil catenas in our digital soil mapping approach, together with co-authors here mentioned on this slide. But first of all, some context into our research. I think I do not need to convince anyone here today of the importance of soil in itself, and also of soil class information and the availability of those soil class information. Because what we see still today is that certain areas across the globe still lack accurate and up-to-date soil class information at sufficient spatial resolution. What we see is that in those areas, often we have to rely on global soil products like soil grids at 250-meter resolution. That is excellent for global applications, but for some regional or local applications, more detailed information often is needed. And that was also the case for the Daphne project, which is actually the project within which our research fitted then for the soil part, where actually a decision analytic framework was made to deal with the water, energy, food nexus in the Zambezi River Basin. But of course, soil plays an important role here. So that's what we wanted to look at. And our objectives were actually more twofold. First of all, we wanted to actually figure out whether we could make classifications of the soils in the study area based on a limited number of in-field observations and limited number of laboratory analyses. And on the other hand, we wanted to evaluate multinomial logistic regression as a technique to come up with a soil class map, basically, of the study area. Now, so the location of the study area is within Zambia, which is largely covered by the Zambezi River Basin, as you can see here. So we worked in the gray area on the right map, the Upper Mulungushi River Basin, covering an area of about 2,400 square kilometers. And we selected that area because there was a fast expansion of the larger and small-scale irrigation taking place in this area. And also good to know is that for this sampling campaign, we had about 4 weeks time. So this is quite a large area to cover in that time period. Now, another important characteristic of the study area was a typical geomorphology, as you can see here, with this dendritic network of dambos, as they are called, which are these low-lying areas that get flooded during part of the year, or some areas even remain moist during the entire year. And throughout the study area, this dambo catena actually reoccurred everywhere. So what you can see here on this slide is the basic process you go through when you do a digital soil mapping exercise, with, at the top, of course, crucially important, the ground reference data of the soils. So the soil classification based on field observations and laboratory data. And then on the other hand, another important input are the covariate data, the environmental covariates representing the soil forming factors. They are fed into the model. In our case, we actually made 10 different models with different sets of covariates, which were then later combined into one ensemble soil class map, which we will later discuss further. But first and foremost, essentially is the field campaign and for gathering the soil class data on the terrain. Initially, we designed a conditioned Latin hypercube sampling design, a statistical sampling design to cover the study area. But we soon noticed when we went into the terrain that this was really difficult to really stick to the sampling design, mainly due to accessibility issues, so that we couldn't reach a sampling point within reasonable time, or that we didn't have permission from the landowner, for example. So there we had to think on how can we adapt now this statistical design as to fit our practical constraints within where time also played a very important role. So there we shifted more to this catena concept of the sampling design, trying to cover these Dumbo catenas throughout the study area with various spatial extents to cover the variability as good as possible. And this then resulted in 90 locations where we were able to dig profiles and collect samples. And then, of course, we had to make our classification with the profile observations and the laboratory analysis. Also here, we had some constraints on the budget to derive the physicochemical properties of these different on these different profile locations, as well as the sampling that we took was not based on the horizons, but on fixed depths, so at 30, 60, and 90 centimeters, bringing some complexity into the classification. But of course, we still had our field observations to rely on to then do the classification according to the WRB 2015 version. So I mentioned the other important set of input data, which are the environmental covariates. I will not go into detail, but basically they represent the most important soil forming factors. And here, when you select these covariates, it's important to have a rigorous methodology of doing so, because including or excluding a particular covariate will have a substantial influence on your final result of your soil map. Here, the formula apparently disappeared, but it was the formula for the multinomial logistic regression model that we trained. And we opted for this model because it allows you, on the one hand, to work with relatively small data sets, and it is not a complete black box, which occurs with some other methodologies. So here you could really have an indication of the direction and magnitude of influence that a certain covariate had on the probability of occurrence of a certain soil group. So what this algorithm does is it gives for every soil class or class that you want to model a probability of occurrence for every location. In our case, we worked on the reference soil group level, so we got an estimate for every reference soil group level, the probability of occurrence thereof. And also good to know is that we worked at a spatial resolution of 30 meters. So I mentioned that this technique allows you to work with a limited data set, but there are also limits to that use, of course, because not every reference soil group had the same amount of observations, causing sometimes some numerical inconsistencies in the model. And that's why we opted to create 10 separate base models with different sets of covariates, and then later combine them in an ensemble soil map by equal weights averaging, which allows you to deal with some of those issues. And then finally, of course, comes the accuracy assessment. Now, when we look at the results, we can see here our 90 observations throughout the study area. You see a lot of alkali-sols and lixi-sols, and also that clay-sols and plinto-sols occurred frequently in the data set, but then also you can see the large variability in number of observations per reference soil group. And here it's also good to note that, first of all, the model can, of course, only predict reference soil groups that you put into it. That's the first. And then secondly, it tends to predict the reference soil groups better that have more observations. And this is how that looks like in the field. So here we can see this typical catena that we would encounter with this Dumbo structure, basically. Where at the Dumbo bottom, so the area that was flooded during part of the year or submerged year-round, we would typically find glaze soils and adjacent to it vertisols. And then when moving up the slope, we encountered a recurrent pattern of plintosols with this plintic, often pisoplintic and petroplintic materials, and often sometimes even huge petroplintic slabs coming near the surface or even being completely at the surface. And then when we move more upwards, of course, there is a gradual transition towards plintic acrisols and lixisols. And then at the interfluve areas, really on top, where most of the large-scale irrigation was practiced, we would see these acrisols and lixisols occurring associated with phaeozems. So this is actually a nice overview of the general pattern that we encountered throughout the study area, actually. And the same can be seen here from our model outputs. What you see here is what the multinomial logistic regression gives us as an output with a probability of occurrence estimate for every reference soil group. For example, when looking at the second map of the glaze soils, again, that dendritic network of those Dumbo bottom areas is clearly recognizable in there. And in the next step then is to combine these probabilities and look at every pixel what the reference soil group is with the highest probability of occurrence, which was then selected for that location. And that then results in this map, which is the final product. This is our ensemble soil class map with the reference soil groups, clearly representing the spatial variability of the soils within our study area, and also concurring to the field observations that we did. But of course, it's important here to note that we did our modeling on the reference soil group level, but when looking at it from the classification standpoint, often the difference between a petroplintic acrisol and a real plintosol can be relatively small, whilst here they are modeled as the reference soil groups without the qualifiers. So it's also important to notify this, that these qualifiers, especially when you're talking about, for example, petroplintic as a qualifier that can have vast impact on the land use and land management on a certain location. So that's a good thing to keep in mind, and also something that is maybe an idea to still do in the future is to not only look at the reference soil groups, but we could do the same exercise on the level of the diagnostic feature, for example, to make an estimate on the probability of occurrence of this plintic, petroplintic, or pisoplintic horizon in the soil, which might be very useful to know for the actual land users in those areas. When we then look at accuracy, here we see the result. In the middle is what we reached with our final product of the soil class map, the ensemble soil class map with a kappa coefficient of about 0.36, which is considered as in fair agreement with reality. Of course, this product is far from perfect, but as we compare it to information that was previously available, in this case represented by soil grids, we see that, of course, by adding our observations and our digital soil mapping technique, we were able to increase this substantially. Yeah? And on the other hand, also note that we were able to map 7 reference soil groups, while soil grids at the time only represented 2 reference soil groups occurring in our area, and hence missing a lot of valuable information. And here it's then also important to note that this concurs with the call for continued efforts for fieldwork and adding to our list of observations, because we can only make our models as good as the data that we put into it, of course, but it's certainly true for soils as well. And these efforts are certainly needed to improve and complement extremely useful global soil products, such as soil grids, and to make them more suitable for smaller scale applications on the regional or local scale. And then here, to conclude, I want to give some take-home messages. So first of all, we were able to classify our soils given the limitations that we were working within. And also we were able to use this multinomial logistic regression with a limited number of observations. And then secondly, important was that given the difficulties on the terrain for the implementation of a statistical sampling design, we had to shift to this Dumbo-Catena approach, where that was used as a conceptual model for pedogenesis to come up with an optimal coverage of the variability within our area. And lastly, we also saw that our final ensemble soil class map performed better than the individual base models, and also performed better than the soil information that was present already at that time via soil grids. So yeah, thank you for listening, and I'm happy to answer questions.
Well, thank you for your nice presentation, and hope you will understand our. That's great.
Yes. Yes.
Okay. I have a very simple question in the beginning. You did all the things with different models, and but in the beginning, the places where you sampled and the analytical procedure, this was in a very traditional way done. So in the future, will it be possible to start with modeling and with the models already decide where you should take samples and which analytical data you should produce?
Yes, indeed. That's an interesting remark, and that's actually what the original plan also was. So there are these statistical techniques to optimize your sampling design, such as this conditioned Latin hypercube sampling or a k-means clustering, where you already take into account the environmental covariates and their spatial variability to cover their variation as optimally as possible. But of course, then when you go into the field, that's a completely different story. And then often you need to rely on on the more classical approaches and these conceptual models of pedogenesis to adapt the sampling design to those conditions, which was at least the case for us, working on a relatively large area with a limited amount of time.
Thank you. And do we have other questions? We must use the microphone, otherwise not possible.
Thank you very much for this clear presentation. I have just one question. On the map, you showed us that you have mostly the soil units which are connected with the tropical regions, like the Lixi soils, Pinto soils, and others. But also, there was clearly visible that it was along the valley of the rivers. There was a lot of Arenasols and regosols, how do you interpret them? Are they connected with the soil erosion which is in this region or in other way?
Yeah, indeed. So there, the regosol and arenosol, I clustered them in one group because we only had one arenosol observation, and then it would give difficulties in the model, but they were anyway closely similar to each other, the regosols and arenosols that we encountered. But they indeed also were seem to occur more on the slopey areas and seem to develop in columbic material. If that answers your question.
We have more questions? Okay. Sergey Sedov.
Thank you very much. This is really a very interesting approach and very interesting model for soil mapping. I think the key element here is the establishment of probabilities of certain soil classes. And my question is, I didn't understand quite well, how did you ascribe the relative weight of environmental variables for definition of position of certain soil group? What was more important? What was less important? I see that finally the map is mostly according to relief, but there are some other variables, yes?
Yes, so the most dominant factor indeed was those associated to relief. So we had multiple indicators thereof, elevation, relative elevation, slope, etc. And were really those that played the most important role. For example, the climatic variables didn't really have a substantial influence, we think, over the size of our study area. So this geomorphology seems to dominate it, but of course that is not the case for the plintosols for itself, because they tended to occur more in the south of the study area. But that's then more related to historical climatic conditions, which we did not really capture in our covariates, I think. But that's a difficult thing to do.
Thank you.
Thanks. So we have one more question. This will be the last one.
Yes, my question is not that scientific, because I wanted to know, maybe I missed that part, if local communities or local people have participated in your field work, and if the results from the laboratory are also local results or from Belgium.
So the fieldwork was done by me and my then supervisor Mulenga Kalumba, who was originated from Zambia. And we also were assisted by 4 locals who helped us with the pits. And then the analysis we did in Belgium. So we flew the samples to Belgium, and there also were then limited in the amount of samples we could take, of course. And then the samples were analyzed at the laboratory at the university in Belgium.
Okay, so we have to close. Many thanks again for your excellent presentation and discussion. I would like to keep you in the auditory here, but this is not possible. But it was a successful approach with this virtual presentation. Thanks again.
Thank you.
I'm sorry, I was told yesterday that the connection with Sergey Koryakin, who is the next presenter, was confirmed. But meanwhile, I have to announce that the official next contribution of Carla Guillen is was removed. It will not take place. But we would like to go now in time to the presentation of Sergey Koryakin. Should not connected. Should we wait for 3 minutes or? Yeah, we can wait. I would please be patient. I will go to the restroom as well, and we will wait for 3 or 4 minutes if we can make the connections. Yeah? Okay.
Oh, thanks. Why not? The microphone is here and it's working.
Okay, I think we should begin, because if we want to ask the last one to take a seat, it will take too much time. Hello, Marcin Svitoniak. We wait for your presentation and we hope that we can discuss this also. And it's on the diverseness of soil units according to the WRB, developed as a result of truncation in northern Poland. Okay, please go ahead.
Thank you very much, Carl, for this invitation. Ladies and gentlemen, I'm from Poland, also like a big group of the participants here. And today I'm really glad that I can make this presentation in the normal, not the distant mode. Today I will talk about another type of the changes of the soil cover in young glaciation areas. If I am talking about the young glaciation, I'm thinking about the morainic areas which was covered by the last glaciation. So it means that for 15,000 of the years, they're of course not glaciated now, but they still are full of the features which are connected with the last glaciation. So that's why I'm calling it the young glaciation area. And yesterday, Marcin showed us beautiful examples of the transformation of the soils due to the, let's say, changing of the water in the soils which are hydromorphic. And today I will talk more about the erosion, another problem that we have in our region. If you would see on the general map of the world, of course, the soil erosion is not the main, let's say the Poland is not the area which is covered by the main transformation of the soil erosion. There are many other countries and regions which has more severe problems, like this one, for example, where the soil cover is almost totally eroded. But also in Poland, you can see that the north part and the south part can be somehow transformed by the soil erosion. So it means that the soil erosion is stronger, more faster than the soil processes. So it means that some soils, a lot of soils can be shallower due to the erosion. In the south part, maybe I will show on this map, this is the models of the potential and actual water erosion in Poland. So you can see the actual erosion, it's of course the biggest one, it's in the mountains in the Poland and in the also in the areas of the less deposits, but also in the north part, which was covered, as I told you, by the last glaciation. So it means that we still have here the hills, the depressions, a lot of slopes, and it's highly under the agriculture uses. We have this weak or medium erosion in general. This is also the our voivodeships, so it's the administrative unit that we have in Poland. The Toruń, my city, is located here, but you can see that mostly on the slopes of the rivers, on the subglacial channels, and also in the morainic areas, we have a lot of potential erosional processes. This photo, for example, was taken 3 or 4 years ago after just one of the rain that we had in the Poland. And this one was in the last year. It was just one night with the heavy rain, and you can see that we have 10 centimeters of fresh colluvium, which came down through the slope. Especially now, if we have these corn plantations, it's very rapidly. So it's just to show you that we have a lot of problems with the soil erosion. If you are walking through our landscapes, especially in the morainic landscapes, you can see beautiful changes in the colors. These beautiful changes in the colors in the uppermost horizon, plowing horizon, are connected, of course, with the topography. You can see that in the uppermost part of the hills, it's the very light brown colors. There is the brown on the slopes, on the upper part slopes, then the gray, and the very dark gray in the depressions. And it's connected also with the erosion. I will show you in the next slides. This is the piece of the orthophoto map, and you can also see the beautiful changes of the erosion. This one is like, I don't know, 200 meters from here to here. All of these very light areas, which are, let's say, the oval in the, or rounded in the shape, there are the hills, which are with the soils, which have very light in brown colors of the surface horizons. Then we have the brownish rings around of them, and it's the upper part of the slopes. And then in the lower part of the slopes, we have light green, or even in depression, very dark gray, sorry, not green, but gray colors. Of course, it is connected with the changes of the soils itself. And you can see that here we have the eroded soils, here a little less eroded, and here's the accumulation of the colluvial material, sometimes on the materials, for example, that yesterday Marcin showed us. So the hydromorphic soils with very well-developed humus or even organic horizon. And it's strictly connected with these colors of the surface horizon and with the topography. Of course, now we know that it's mostly connected, if you are talking about the upper part of the hills and the summits of the hills of this morainic materials, that it's connected with the erosion of the soils, which previously were the alluvial soils, were the reti soils, so the soils with beautiful alluvial zone, and of course the alluvial horizon, which was primary before the erosion started on the depth of the 80 centimeters, 100, something like this in general. And of course, partially it was during the time eroded. What is the time of this erosion and the ratio? Of course, in the another slopes, in the different slopes, it can be differ. But in general, in our area, the cultivation started many hundreds years ago, sometimes even in the before the medieval times. So every year it's just, you know, sometimes 1 millimeter, sometimes 2-3 millimeters per year, it's going down. So at the end, now on different slopes, we have soils like this one. So we have the argic horizon just under the humus horizon, and these soils, maybe this, so it's more where this argic horizon is plowed into the humus horizon. We can visible them on the surface as these brownish rings. And the soils which are totally eroded because they contain the secondary carbonates, which primary they were moved down and accumulated with the percolated water in the depth like 100, 120, 150 centimeters. Now they are on the top of the soils, even in the humus horizons. So in general, this totally eroded, maybe not totally, but very strongly eroded soils look like this. That we have only the weakly developed humus horizon and the parent material or some kind of the B horizon with the secondary carbonates which are here. And yeah, they are very clearly visible on the orthophoto maps, of course, but they are not so homogeneous. Of course, they have only two horizons. This is the common feature of them. And under this, they have more or less bigger or smaller amount of these secondary carbonates. But sometimes they have also some glake properties or stagnant properties that are visible on this right side. Sometimes they're more dry without these features. Sometimes these humus horizons are well developed, sometimes are very, very weakly developed. So we decided to make the investigation of them. So check the method of how we can easily find these soils in the field. And you will see that it's very simple method. It's even my daughter, which is 7 years old, she can make it without any problems. Then estimate what is the share of this totally eroded soils. And then this is the, and also the determination of the main properties of the soils. And thanks for that, also make estimate the systematic position of them according to WRB. On this slide, you can see that sometimes it's so clearly visible in the field. Yes, this is covered by the trees, by the forest. Here is beautiful developed alluvial soil, and here is just totally eroded soil to the parent material. Okay, today I will show you only the soils which were located in the Chełmża commune, in the small administrative unit. It has 180 square kilometers. Mostly, it's covered by the glacial morainic plateaus. Some of them are more, let's say, flat. Some, like this light brown, it's more undulating or even the hilly morainic plateau. In the central part of this area, we have also the subglacial or the tunnel valley, which was developed under the glacier. You can see that the topography of this area is really, let's say, intensive. So it means that it's not flat. We have a lot of hills, a lot of depressions, a lot of slopes here. So it's very good to have the studies about the soil erosion in such areas. This is just the general view of the soil cover, but this map was made from the soil agricultural maps. So not according to our investigation. What I would like to say that mostly it's covered by the alluvisols and retisols in the maps which were made in the 60s. Sometimes we have also these brown areas, like here you can see this dark brown, by the soils which were called in these times on these maps as cambisols. But please remember that now we know that they are eroded alluvisols, not cambisols. And also this black one that you can see here, there are soils which are in the depressions with the thick humus horizon, like a molic or chernik horizon, and with the glake properties. So it's, for example, chernik glacials, molic glacials sometimes, or even the glake chernozems. Like here you can see, this is the area of this, let's say, alluvisols, eroded or not. Here is this chernik glacials. And the methods that we use to find these eroded soils, it's very, very simple. It's enough to have the orthophoto maps with the areas which were just plowed, so without any cover of the plants. And you can see this beautiful brownish rings around. This is the eroded alluvisols with the BT horizon on the top. And inside of this, let's say that on the top of the hills, there are areas with the soils with very, very light brown colors in the arable horizon. And this is this eroded soils. In general, we can divide them into two types. One type is in the a little bigger hills, which are with the good drainage in the soil. Sometimes it's smaller hills, which are, for example, like this, surrounded by the very black in color soils on this orthophoto maps. And they have the not so good drainage with a lot of features which is connected with the stagnation of the even ground water. So this method is really easy and how many contours with this we found in this area? It was more this totally, let's say totally or strongly eroded with this very light color on the top. 700 contours. Unfortunately, we could make it only in the 30% of this country because 70% was covered by some crops or other things, so we couldn't make this investigation in these places. But in general, they covers this contours 1% of areas where they could be estimated. So we can say that this eroded, strongly eroded soils, they cover 1% of the whole area. Another one which is very important is that it works So first we found it on the orthophoto map, then we go to the field, and then we check, is it true or not? And we made a lot of drillings, like, I don't remember now, but 90 or 100 of them. And 96% our estimated was good done. So we can say that it's very, very easy method to find this soil. Maybe this one, it's not so important here. In general, we can see that all of this area is strongly transformed by the erosion. Of course, in some areas, these totally eroded paddons had more than 1%. In the very undulating, they could even cover more than 5, 7, 10% on some sub-areas. But in general, it was 1%. And what we found according to the main properties. As I told you, mostly the weakly developed or not weakly, the humus horizon and the parent material with secondary carbonates, sometimes with the gleic properties and others. This is just which laboratory test we made, so it's very standard analysis. We also, of course, checked all of the diagnostic criteria of the color, of the amount of the humus, organic carbon in the horizon before we made the soil classification. And what we found. You can see on this graph the main features of this soil. First is what was the amount of the secondary carbonates. You can see that this, let's say, line divided into two groups. This group is where the secondary carbonates were enough to say that we have the calcic horizon even. This group is with the protocalcic, sometimes even in some cases just the calcaric, but still with some carbonates. Another, let's say, two groups is this one is connected with the soils which are more or less dry without big influence of this groundwater or stagnation of the water. Here is the group of the soils which have this influence. And the last, which is important, is the amount of organic carbon and development of the humus horizon. Is it strong enough to be molik or chernik in this part? And this part in the left side, is it not enough? So it's just, for example, the ochric. Ochric as a qualifier in the WRB. We can see that the biggest group is this one, but I will show you all of them one on one. So the 73%, this subgroup, it's a soils which we had to classify as eregosols, but with protocalcic qualifier. Unfortunately, this protocalcic is in the supplementary qualifiers, so we couldn't express it in the name of the soil. So this utric, regosols, aric, protocalcic, loamic, and ochric. So you can see that if we have such soils, we are almost sure in Poland that it's very eroded soil in most of the cases, of course. Another one, maybe it's not so common, but we found also two examples in this area, but in my, let's say, in the past, I found more of them in the Poland. There are soils which have enough, more than 15% of the calcium carbonate, with a lot of course, the secondary carbonates in this second horizon. So they have to be classified as calcisols. So please remember that also in Poland, and I know that it's the same situation in the Lithuania, in Germany, in the Czech Republic, and other countries in our region, that we can find the calcisols. And privately, for me, it's not a problem. Some pedologists are not so happy because the calcisol are traditionally connected with the arid soils, with the accumulation of the secondary carbonates because of this going up of the water, yes, and precipitation of these carbonates. But in our cases, it's because it's the excavation of the horizon, of calcic horizon, which were on the depth of 1 meter, 1.5 meter previously before the erosion started. So please remember that we also have this calcisol. Sometimes in some places, in the places where the erosion in the last year was stopped because of the, for example, putting on the top of the soil the grasses, or as you can see here, by the strip till, which is more and more common in the Poland. So this ochric, let's say, or not horizon, but this humus horizon, which was only ochric, they were developed again into the molik. So now we have the situations also only two cases, or even one case, that we have the Molic horizon here on or calcic horizons, or protocalcic. So we have, of course, the castanozems also in Poland. And I think that amount of castanozems will grow and grow if we are talking about the soil classification, because this tillage, no tillage or reduced tillage practices are more and more common, and it's really stopped erosion and makes, again, the development of the humus horizons. In my case, it's also very good pedo indicator of the changes, this WRB position of this soil. So you can see, yes, the example of this soil is still plowed, and amount of this, for example, the organic carbon is only 0.5%. You can see the color is almost like just the glacial till, and here we have the almost 2 times more after 15 years of not plowing, just changing into the strip till. Okay, of course, some of the soils were also connected with the high influence of the ground or stagnation of the water. Some of them we had to classify as a molic glacials. In general, they have better developed the humus horizon because the soil erosion is not so fast in these places. Sometimes they had to be classified also as stagnosols, because please remember that they are all still on the top of small hills. Sometimes it's not the influence of the groundwater, but the stagnation of the water in this material. And if we have no other diagnostic horizon, so they had to be classified at this. Okay, so this is the end, the main conclusion. Maybe I won't read this because I already told everything. Please remember that because of the soil erosion, we have a lot of regosols, protocalcic, calcaric regosols, but also in some cases the calcisols, which can be the pedo indicators of these processes in this case. And if the erosion is stopped and the area, sometimes due to the high inclination of the slope, is changed into the, for example, the pasture, and there is now it's covered by the grass. And sometimes because the strip till, even more often it is this situation, it is changed again into the, not again, but it's development of the humus horizon, and in the classification it goes, the soils will go to the castanozems, and we also find, for me it's not a problem, but for many people it is. So maybe this is the main conclusion that it's from this presentation. And a lot of such situations you can find in our soil sequences atlases that we made. Now we will be the 5th edition in next month. I think that it will be ready. You can find there a lot, all of these catinas, very good described. Of course, a lot of articles about this. And thank you very much. It's everything.
Thanks a lot, Marcin. We run out of time, but one question I would allow. Where is it? Sergey. Give him the mic.
Then I will try to speak as loud as possible. Marcin, thank you very much for this presentation. Of course, my question goes to the calcic qualifier and to the fact that you define castanozems and calcisols in the Baltic area, which is for traditional approach is something really shocking.
Yes, I know. That's why I wanted to show it.
Yes. Something in between podzols studied by Michał, for example, albiluvisols, retisols, luvisols, castanozems, and calcisols. So my questions are in some way technical. I think they are developed above or on calcareous moraines which have quite a lot of primary carbonates. How do you discriminate between primary carbonates and secondary carbonates, especially taking into account that you must quantify them? relative abundance of primary and secondary.
Please use the mic.
Okay.
This was only one question allowed. Okay.
And that's all.
It was estimated in the stage of the field investigation. They are really very beautiful, the secondary forms of carbonates. They're so common. They are on not all, but on a lot of PET faces, on the stones. They also form beautiful pseudomycelium. On the roots, sometimes you can find something that previously it was the root, now the root decayed and you have beautiful secondary carbonates. So it's not a problem to distinguish. The bigger problem is to say that we had the primary. Of course, we know that in the past they had to be primary, but mostly in the field we can find a lot of secondary carbonates. So the problem is also, now we will have the article about this, that sometimes even in the stage of the field work, we just throw out some of the secondary carbonates because they are big, so we are not taking them into the estimated in the laboratory. So even the amount of the calcium carbonate can be a little underestimated in general, of course, in these samples. But yes, it was in the field. And of course, in this area, we have some micromorphological investigation. So in this case, it has no doubts about this.
Thank you.
Okay, thank you both. Thanks for your contribution. And now we continue with, I say, Josef Warosewski. Is Josef? Okay, sorry about that. Okay. And, well, it's about trajectories of thick humus-rich soils transformation under erosion and deposition processes in southwest and southern Poland. So we stay in Poland. Go ahead.
Yeah, hello everyone. So yeah, just like Carl said, we will stay in Poland, but we will change this substrate. So we will again focus on erosion and the trajectories in thick humus soils. It was a pleasure to be part of the larger project of my colleague, and also I tried to combine here results of my PhD student. She was not able to come. So we will touch basically two topics. One topic is related with the trajectories of erosion, of transformation of soils. The second one is more related with the soil redistribution rates. So it's really nice to know when the soil will disappear, and it's nice to calculate the rates. I do not need to really convince you that the black soils or thick, rich humus soils are quite important for us, for the food security. Yeah, they are kind of a heritage of the past land use, our history. In Europe, they are mostly associated with the loess deposits, but not only, of course. Because of criteria, classification criteria, we can really find the Chernik and the Molik diagnostics in many types of materials. So they are not only related with this classical view. So you are aware of the fact that there is a kind of a initiative called the Black Soils, and this is quite active. We already discussed with Cesare that is a bit maybe less in some years, but of course it's we know why. The black soils are really important into global change mitigation. They are so important for us, and we really should protect them. Regarding the classification issues and what's really fall into this really wide basket for the black soils. So we would have here well-structured dark colors surface horizons, right? This is clear. We have a nice experience from the Mexico about that also, right? And high base saturation, moderate to high organic content of organic matter. These soils, however, need to fulfill some classification criteria. Because I'm not a really specialist in soil taxonomy, I will follow in this presentation mostly WRB criteria for distinguishing Ternich and the Molic horizons. We locate our sites in the southern Poland, from the western to easternmost part of our country. So we are a bit moved to the south in relation to the study sites of Martin, that were presented some minutes before. And you can see here the really nice loess belt, European loess belt. In Poland, we have quite a lot of loess deposits and loess derivatives that they serve for formation of Ternich and Molic or soils that hold this black or dark rich organic rich horizons. You know that the loess it's a really specific material. It was related with the Fennoscandian ice sheet activity. The loess that was deposited here in the southern Poland is mostly of at least the uppermost part is mostly a late glacial maximum loess. There are some late glacial, of course, younger than the 30,000 of years. So we have something like a 24 to 14,000 mostly. I mean the really top loess materials. But of course we have a really long record from the Imean period. So we have a really thick loess, but we also should bear in mind that the loess was not only deposited as a really thick deposits. In the landscape, we have a lot of thin pedoturbated loess that really mantled different landforms and is quite widespread. So it influenced soil formation, just like here we have a loess over a granite slope, serpentinite slope deposits. But that's not the case for this story here. Our 4 sites were located here. Basically, there is no really high variability of the mean annual temperature, mean annual precipitation. So it's some variety from 9 degrees in the west to the around 8 in the east. So the mean annual precipitation is also quite varied, slightly more than 500 here in the east, in the Volhynian uplands. It's a bit higher in the Carpathian foothills here, more than 700 millimeters. So the conditions are more or less quite similar. However, the relief it's much different, and you will see them in the next slides. So we will start with the Lower Silesia, so the western part of our country. So here we have mostly slightly undulating loess plains. There are not really strongly inclined slopes. Long, gently slopes here result in the Chernozem's presence, at least in the middle part of the slope. That's the hilltop. Here is a toe slope, more or less. The starting point for the thick humus-rich horizons is more or less some haplik Chernozems. However, here we mostly found only alluvic, which is more or less the next step of the transformation. So the transition zone to the BC or CK horizons, already in the lowermost part, we detect some clay illuviation. So the topsoil is already strongly truncated Luvisol, which is really similar to the locations that was presented to by Marcin. And eroded material that was feeding the middle part of the slope also enlightened a bit the molic or the black horizon here. Therefore, we have a castanosum here, not the Chernik, but the molic. So it's also break the conceptual idea for a presence of the castanosums in our region in general, right? And the lowermost parts, they always suffer from some stagnation of the rainwater. Yeah, the rolling hills in the south and central part of the Poland. So again, we are more or less started from the Celtic Chernozems here on the long and inclined slope that terminates with the waterlogged depressions. So here it's a quite clear the dynamic water table or active water table level, and the hills. Well, that's a quite common situation that was discussed before. Sergey asked about it. Yeah, the haptic calcisol. So the loess was all not always, but often was that strongly eroded that also exposed the older lithologies. And in some cases, this really results in this verification or evaluation of the Celtic horizon. In less inclined slopes, we found the Luvic Chernozems, and in the toe slope, we had a quite thick column material that meet the requirements for the pike. And forested hills in the agriculture used slopes. Here we have two sides, and these sides are a bit different. So in the two previous sites, we only have the agricultural lands. Here, the top it's always forested. And two types of the catinas and two types of the transformations that we detect. So Luvic Thiozem and Haplik Chernozem in the mid of the catina. In the upper part, Luvic Chernozems, quite new to the forested sites. The lowermost profiles, they are quite thick colluvium materials, and under the forest we had this nice typical albic luvisols. The dark humus horizons was destroyed under the forest was gone. So the PhD students of our team try to estimate the long and short-term erosion rates in the lost landscape. We didn't do it on the black soils. In fact, we focused on a luvisol dominated landscape. But what are the conclusions? Yeah, we choose two indicators of erosion. The one is tin beryllium, an in situ indicator that developed in the lattice of the quartz. So this long term means that we can go far to even more than 1 million years. So the rates didn't cross the boundary of 1 ton per hectare per year. Basically, the tolerable erosion rates for Europe, for the grasslands, for agricultural lands, is around 1 ton. So here we do not see a really strong imbalance. However, the short-term erosion rates that was calculated with the plutonium, it's in fact replaced recently the cesium 137, showed a large increase of the erosion. So we can go not more than 60 years back in the history of the sites with with the plutonium. So it's quite strong and really show the acceleration of erosion in a recent decades, 6 decades. So what we found on a hilltop, we found a nice albic Louis soils with the BT horizons, and because of a strong erosion and the further mixing and incorporation of the BT horizon into the A horizon, it was also showed by Martin, we have a strong reduce of the BT. So soon these soils will gone. And what is the output? The output is basically a regosol after that. So based on the calculation of erosion rates, we can say that in some extreme cases, on strongly eroded sites, we have only 80 years for preservation of the BT. Just like similar with the margin data, we found from the one rainy event to another, remove of the material around of a thickness of around 6 to 10 centimeters of loss. So each time, right? So yeah, the data, there are some published, and the conclusions. So the main pathways. So the haptic Chernozems as a more or less typical soils for the lost belt may transform into Castanozems when the topsoil is a bit enlightened and will not fulfill criteria for turning. In the colluvial material, we mostly have a phaeozems with some water related features. The further or presence of clay alluviation led to the Luvic Chernozems formation and further truncation to the Luvisols. Strong erosion will meet or will reach the point of the calcisols or the regosols. So what is important that the thickness of the less mantle and how strongly it will be eroded. We still don't have a lot of precise data about the soil redistribution rates regarding the Chernozems and the phaeozems. And I think this is a missing puzzle that we should really found and fill. Regarding the new proposals of Chernik, but maybe the time is running out. I guess it is. There are nice two suggestions from the Peter. I think that when we consider also a plat layer, then we should rather reduce the amount of the Castanozems and have more Chernozems, maybe, or at least the Chernik. And also the increase of the average of the aggregates will help to sustain the Chernozems that were developed mostly from the more clay materials that will produce larger aggregates. That's something that I wanted to say, and that's the full team. Yeah. Thank you very much.
Many thanks. Your contribution was also a partial answer of Sergey's question about organic matter and its change in your landscapes. Now, we have a question more, please. Sergey, again, come up.
Sorry for being so insistent, but these topics are so interesting, and this contribution of Yaroslav in particular is very important for the whole problematics of black soils in Europe. There are some research in Germany, Czechia, and so on. I will go directly to the specific problem which I would like to ask. Profiles with black horizon, most black at some depth, and lighter colors above. There could be two reasons for this. Degradation of earlier thick black horizon and loss of humus due to mineralization and development of these luvic properties, or covering with colluvial materials with less humus and lighter color. I think it has also implications for classification. In one case, it will be, in the second case, it will be colluvic, and in the first case, I don't know what it will be. What are criteria to distinguish one or another way of development of such horizon sequence?
Please use the mic.
Regarding the second case is more common. So we mostly have the covering of the lightened material of the topsoil. And if we really have this enlightened only on the topsoil, it might came from the plowing, of course, and the clay accumulation always appear in the subsoil, so in the second A horizon or the third A horizon, right? For me, the second case is more obvious for this situation. So how to distinguish them? How to distinguish them in the field? It's, of course, we have a lots of things related with the landforms, with the relief, right? Then it's easy when we are a bit lower in the landscapes, right? So then it's much more clearer. Yeah, sure. Yeah, but in the slope position, we of course can have some kind of a lateral flow that will increase this clay translocation. And of course, just like you see here, the sluvic chernozems, they always appear on the slopes. Yeah, so that may be also present. So I'm not sure if you are fully satisfied.
Not fully.
Sure.
Not fully, because you give more factor criteria, but not substantial criteria.
Okay.
Okay, we thank Jaroslav Waroszewski.
Sure.
And we come back to Mexico. Elizabeth Solero will present us talk about soil degradation in the basin of Mexico, problems of classification. The floor is yours, Elizabeth.
Thank you. First, I want to acknowledge the organizing committee to allowing me to present this work, because I am not dealing with soil classification, really. I work with paleosols. Unfortunately, classification of paleosols is something very complicated because the paleosols lack of diagnostic features or horizons. And this is a pity because soil classification and paleopedology have different ways. They don't merge. But this year in Glasgow, we will have a common session, soil classification and paleopedology. So maybe this is a way that we can find a common way to see the classification of paleosols. But today I will follow the road of the previous presenters, talking about degradation of volcanic soils. And I will start with this map. This is Mexico City in pre-Hispanic time, more or less 2,000 years ago. And we have in the center of the map the occurrence of the lacustrine bodies surrounded by volcanic structures. The southern part of these volcanic structures are Pleistocene and Holocene, while in the northern part we have older volcanic materials. In the map in the right, we can see Mexico City today. And we have two different areas. In the northern part, marked with this reddish color, we can see the urbanization, and then all the soils are sealed by the constructions. In the southern part, we have the conservation zone where volcanic soils occur, and they are still present in this area. This area, conservation zone, has been very attractive for agriculture, not only today, but in the past, because in this area, agroecological systems occurred. And in this area, the famous chinampas, that is technosols constructed by pre-Hispanic cultures, allowed people to growing crops during the whole year. During the colony, we have a big transformation of the landscape because of the moving from the chinampas to the hill slopes of the volcanic structures. And the Spanish conquerors brought to Mexico the cattle, and then the rising of this cattle provoked extensive erosion in the area. Now let's see what soils we have in this area. You can see here, this is the conservation zone, and we have mainly andosols, we have veozems, leptosols, histosols, and glacisols that correspond to the chinampa areas and the lacustrine areas nowadays completely, or more or less completely dried. Let's have a look to this area in the square. We have, once again, the andosols together with the veozems and the leptosols. And I want to associate this kind of soils with the parent material, that is the volcanic ash. So we have these two maps showing the main volcanic structures. We have one in the north, the Teutli volcano. We have the Tlaloc volcano. This is a big stratovolcano with many eruptions in the area. Lava flows going through the north. And Popocatépetl volcano is not shown in this map. It is located a little bit more to the east. And in this photo, we can see an area, sorry, the pointer is not well, but let me see if, yeah, here we have two more volcanic structures. This is the Ayaquemetl volcano and the Two Cerros volcano. So what are the questions that we put regarding soil classification? Andosols are young soils. And several works have documented the transition from andosols to other soils in 10,000 years. In Mexico, we have observed these transitions in many places in the Trans-Mexican volcanic belt. We have luvisols in volcanic materials older than 10,000 years. But I'm sorry, I forgot to say about the ages of the volcanic materials. You have here, the Teutli volcano has an eruption 36,000 years ago. We have Popocatépetl volcano with two big eruptions in 17,000 years BP, and another one 6,000 years. And the rest of the volcanoes have eruptions around 14 to 6,000 years. So with this perspective, we expect to have more luvisols in the area. but we have no lubisols. Well, what is the reason of this? And the feocems that we have found in this area are because of the land degradation. And another thing is that the area has been cultivated for a long, long time. The anthrosols that we have observed here are, all the cultivated soils are anthrosols or not. I have to say that we didn't analyze all the qualifiers or all the diagnostic features, and then our classification is mainly based on morphology and some analytical properties. So this is the area that we study, the Teutli volcano located here, and the Ayaquemel volcano that is located more to the south. Here, we have several profiles, but I will show only three, sorry, two in the Ayaquemel volcano and one in the Teutli volcano. The idea is that you see the kind of materials we have, polygenetic soils, paleosols, and eroded, degraded soils. So this is the first profile, is located in the Ayaquemel volcano, in more or less at the top of the volcano. It is still under forest. And you can see here that this is polygenetic soils with at least 3 cycles of soil formation. We identified the Tutti Frutti pomis. This is from the Popocatépetl volcano in the bottom of the profile that is 17,000 years BP. The other materials, we don't know the age. Let's see some of the properties of these soils. They have a positive reaction to this phenolphthalein test. So maybe this is a proof of andic properties. They are very silty. We have a low bulk density in all the materials, and the pH is more or less neutral, and the total organic carbon in the top is around 2.2%. Now let's see some images of the thin sections. Micromorphology is one of our tools to evaluate several aspects of our work. But in this case, I want to use to show the nice granular spongy structure typical of andosols in this area. But besides this, we can see some tephric materials. For instance, we have this pyroxene in the center of the photo. This is an olivine, this olivine that is very fresh. But together with this fresh material, we have very strongly weathered minerals. So this together in one horizon. Besides this, we found charcoal. We have these rounded fragments in the center of the photo, and that if we see with more amplification, we can see that it is the rest of a soil that was eroded and incorporated in the soil. So we have some colluvic material inside this polygenetic soil. So what about the classification? We can say that this is an andosol. Sorry, because of these qualifiers, maybe they don't fit at all the correct classification, but I try to do this exercise that we have these colluvic and siltic properties. Okay, this is what we expected in the area. We don't have any lubic feature because the material is reworked because of the volcanic activity as well as by colluvial processes. And then let's see the second profile. It is located 1 kilometer down slope of the Ayaquemel, and this is an agriculture area. And here we have the complete profile. It is very similar to the previous one with these 3 cycles of soil formation. But the main difference that we have observed here in the modern soil is that we don't have this positive reaction to the test of the phenolphthalein, and the amount of organic carbon is a little bit lower. Another interesting thing is that the farmers built terraces and they removed the topsoil and they left the paleosoil, these two ABW horizon, in the top of the terrace. And then now the paleosoil is in this terrace and they are cultivating in this material. So we can expect some changes in the soil classification because of the use of this paleosoil. Let's see some of the thin sections that we have done. And here the structure is not similar to the Ayakemet volcano. The material is more loosey, more porous. We have less dark material in the ground mass, but we have also these materials, surrounded materials that are from soils, reworked soils. So once again, we have here this colluvial material incorporated in the soil. Additionally, we observe charcoal and these areas with like crust in the photograph of the left side, like crust maybe of the former soil, of a former soil. What about the classification? In this case, I don't rely, this is an andosol, maybe this is a phaeocene, this is a question for you. And the paleosol probably is a cambisol, I don't know. But what it's interesting here is that this paleosol is now incorporated to new pedogenesis. And last profile, it is located in the Teutli volcano, in the foot slope here. And here we have the most degraded soil. You can see here the area. In this terrace, the farmers have been cultivated for more than 60 years. And what we observe is a lack of organic matter in the top, at least lower, much lower than in the previous site. The bulk density is higher. And additionally, we have here the Teutli ashes that date to 36,000 years. But it is an antisol, regosol. I'm sorry, I am now mixing the classification. But let's see, what about the structure? We have a very loosey structure. The material is somehow dispersed in the ground mass. We have this tephric material once again, and but we still observe the rest of the granular structure of the andosol phase. Very degraded, but it is still present. So we decide to classify this soil as an anthrosol because it is cultivated for a long, long time. And the question is that if we have all the soils in this area of the Teutli volcano, the cultivated soils in the Teutli volcano, in this way of classification. We don't know. We are in progress with this investigation. This is the general conclusions. We have these volcanic soils that in the natural condition are andosols. We don't have luvic features because the ages of the volcanic materials are younger, and we have this colluvium that is incorporated in the soil, and then the zero time restart the process. Okay, this is the end. Thank you.
Thanks, Elizabeth. Okay, the presentation is open for discussion. How's about? Okay, please go ahead. You say your name, I forgot it.
Alberto.
Voy a hablar y tú me traduces.
Okay.
Realmente los impactos de la actividad humana en el cambio de las propiedades de los suelos es muy importante hoy en día en la clasificación de suelos.
The anthropogenic impacts in the soil classification is a really important thing.
En estos tres trabajos se ve cambios de tipos de suelo, grupos de suelo, por influencia de la erosión o del cultivo.
In the past three works, we have seen the influence. In the past three works, we have seen the influence in the change of the group's classification for the anthropogenic activity.
Yo pienso, por lo menos lo tenemos en nuestra clasificación de Cuba, en la última versión, que hay que poner, en estos casos nosotros ponemos como subtipos agrogénicos o aerogénicos con su diagnóstico.
In the case of Cuba, in the Cuban classification, we name it aerogenic or aerogenic or anthropogenic.
En unidades de la clasificación se pone la intensidad, mediana erosión, fuerte erosión, etc.
And we also classify the intensity of the erosion, high erosionated, medium erosionated, low erosionated.
Cuando el suelo está completamente erosionado, nosotros le llamamos aerosol de tal tipo de suelo.
When the erosion is really bad, we call it erosion of some of
Erodosol. They name the soil erodosol.
Erodosol.
¿Por qué? Porque eso es muy importante en los mapas.
Because that is a really important thing in the maps.
A la vez que se dice aerosol, se sabe que ya perdió completamente el horizonte A y el horizonte B.
When we call the aerosol the layer A and the organic layer, it's gone.
Ponemos de qué tipo de suelo.
And we also associate
Aerosol de suelo alítico, aerosol de suelo pardocialítico, etc.
we also associate the erosion to that specific type of soil.
Pienso que eso es importante tenerlo en cuenta para reflejar realmente estos procesos de transformación que ocurren en los suelos por la acción antropogénica.
So I consider that type of classification, and to be specific, it's really important for the classification. Thank you very much.
Yes, thank you, Alberto, for these comments, because we observe that agriculture, we eat from the soil. This is something that maybe we can stop completely. But the bad practices during a long term go to this kind of degraded soils, and now we have to invest money to improve. For instance, in this project, what we are intending to do is to improve structure and the organic matter content using different improvers of soil.
Peter.
Okay, so thank you for your information about the results of management. But for sure, long-term agricultural cultivation does not change any soil into an anthrosol. Only specific measures do that. So the soil you showed for sure is not a plagic anthrosol. You must read the definition of the plagic horizon and the criteria and apply them. And one of the criteria is occurs in locally raised surfaces. Also for terric, for erratic, locally raised surfaces. For others, certain amendments or certain cultivation measures. Also the undersols. You call them a tephric undersol, but every undersol has at least one of the following qualifiers: vitric, aluandic, and sillandic. Vitric properties or andic properties with sillandic criteria and andic properties with aluandic criteria. At least one of them exists, sometimes two or even three. So these soils, as you classified them, they cannot exist.
Okay, thank you. Thank you for the input. This is very important. I try to do following the guide, of course, and following what the qualifiers were, but I failed. Sorry.
And may I add to this statement that you say that the androsols degraded. Now, degradation is normally that land use possibilities reduce. Now, in this case, I think it's the other way around. Through this anthropogenic activities, the land use possibilities improve. So I would say they change to in the direction to androsols. It's not a degradation, really, I would say.
Maybe.
Maybe.
Yes, because finally, we don't have the same amount and maybe quality of the organic matter. Because the cultivation changes this kind of organic matter. Then maybe this is a degradation process, maybe this is only a pedogenetic change in the trend of the pedogenesis, I mean.
Yeah, thank you. Now Cesare.
Yes, thank you. I agree with you that erosion, truncation of soil profile is a kind of degradation. Development of, as they were called, erodosols, yes? Our calcisols, Polish calcisols, commonly are already calcic erodosols, we can say. So there are false calcisols, in fact, yes? But what I wanted to say, accumulation of material which produces thicker A-horizon, rich soil, as you shown us, the phaeozems, for example, can we say it is degradation? It is rather aggradation. It is production, yes, erosion, okay, has two sides, degradation and aggradation, yes? For if we analyze it on a slope, there are two faces of the same phenomena, yes? So for us, it is quite commonly observed also in Poland, that in hilly areas, what was shown by Marcin, for example, erosion produces as eroded soils in the upper parts of slopes, yes, and aggraded, thickened, upbuilt, we can use various words, soils, quite often phaeozems in lower positions. So there was even idea that the percentage of black soils in post-glacial areas may be used as an index of spatial transformation or degradation of landscape due to intense land use and erosion, but the black earths or your phaeozems were marks of aggradation, not only degradation. Thank you very much.
But in this case, we don't have any aggradation of soil organic matter. On the contrary, we have losses of organic matter. We have no manures are fertilizers, so these soils are not aggraded. They are degraded in organic matter. And another thing is important is that we were looking for the areas where this organic matter can be located because of the erosional process move from the top to the lower positions. But in the area, thousands of kilograms are taken to sell in the markets as air for the ponds. So people can go to the market and buy this earth and put in the gardens or in the ponds at home. So this is also another very important issue that we have to take into account. We have more degradation than aggradation. So.
Okay, we come to the end.
Yes, thank you.
No,
We have one more. Thank you. Sorry.
Thank you so much, Professor Elizabeth. And my question is related to paleosols. You talked about them in your presentation. And I think sometimes that the paleosols are like in the limbo of names, because rocks have names, soils have names. Even we are in a Congress of names of the soils. And you, as paleopathologist, you think that paleosols need names?
Of course, there were attempts to do a classification of paleosols. There are several works, but all the time we face the problem that we have no diagnostic features that can follow in a more homogeneous way. As Sergey told in the morning after the presentation of Curtis, why we have to do different way of classify more or less the same. So in a paleosol, you can follow the diagnostic features you are watching, but the way that we classify is following what we know, the modern soils. So in this case, it's very difficult to find a real name for the soil. So I think that the paleopathology community just need a classification, but I think that we more or less feel comfortable with what we have. Thank you. That's all now.
Thank you. Well, I must say my first attempt to go into soil science was on paleosols. And what I want and what we should want, we want to understand the soil formation and the processes. And so the classification is not so important in paleosols, but you need more fantasy to classify them than the surface soils. Yeah?
Yes,
Okay.
I think we apply geofiction or soil fiction.
Okay.
Thank you.
Good,
Thank
you do it. Okay, I want to thank all the contributors so far and all the people contributing to the lively discussion. We have now the coffee break, and I would like to prolong it by 5 minutes because I think we have more, then we have 20 minutes coffee break, 35 past 12. Please be here back because this is important that you are back because this is not only a contribution by Peter, this will be a vision into the future. Okay? See you soon. bewegt sich nichts, wenn man das sagt. Okay. Ja.
Ja, eigentlich schon.
Please come in, please come in, please take your seat. Ich gehe jetzt nicht nochmal raus. Please come in, please. I think they hear this. Yeah, I heard when I was out, I heard other people speaking.
But it's not loud enough outside.
Yeah, maybe.
They hear it, but they don't hear it well.
Ja, also ich gehe nicht nochmal raus. Es ist mir zu blöd.
Ja.
Please bring the people in. Please try to find your seat. We are late already. Please, please.
La presentación tiene que estar aquí porque eso es lo general. Día 2. Este. Peter Schad, este. Sí. Okay.
Next.
Yeah.
You
Okay.
will not want to be told all the things which will happen in the future, but it's for soil classification people, it's very important to hear what's going on in WRB and we are also allowed to ask questions, because this will be taken in the discussion which is following. Now, Peter, please start with your presentation.
Yeah, thank you, Carl. Can you hear me like that? Yes? Yeah. Okay. So we are on the way to the 4th edition of the WRB to be presented this year in Glasgow. And many of you have received the draft, which I sent around January 31st. Of course, there have been some changes in the draft. In some days, hopefully, I will send a second draft, at least to the members of the WRB board. Okay, let's do a few words about history. The first edition was in 1998 with 30 reference soil groups. Then 2006, 2 more, the second edition with 32. And this second edition was not suitable to use for mapping. Therefore, in 2010, guidelines for constructing small-scale map legends using the WRB were published. And 2014, with an update 2015, the third edition was published, same number of reference soil groups. And now the idea to serve both classifying, naming individual soil profiles, and also using WRB as a tool for creating map legends. Yes, this is the current WRB. So the editor is the IOSS working group WRB, and the chair team was myself, Conny van Huysteen, and Erika Micheli. And it was in that time published by FAO in the series of World Soil Resources reports. We have a WRB homepage. This is at our institute. And the document you can download from the FAO. And there are 2 apps with Android and Windows. And there are many translations: Spanish, French, Russian, Polish, Georgian, Slovene, and Czech. Maybe I have to do it that way. Okay, so some history, the progress made in 2014, one major progress was the redistribution of qualifiers. So in 2006, we had prefix and suffix qualifiers. The prefix were 2 groups, typically associated qualifiers and integrates. And all the others were suffix qualifiers, among them some very important one, and among the typically associated ones, some of really minor importance. And it was possible to name soils, but impossible to make map legends, because for map legends you need the most important ones, and some were hidden as the suffix qualifiers and some non-important ones in the typically associated ones. Now 2014, we have the principal qualifiers ranked according to importance. Of course, there may be some disagreement. What is important? I say this is important, you say that is important, but I think we more or less got to an agreement. And the rest is the supplementary qualifiers, which are alphabetical. And with that, it is possible to name soils and to make map legends. So how to proceed from, well, map showing soils in the landscape to a map unit? The first step is ignore the soils that cover small areas. That's why we have the dominant soils that cover at least 50% of the area of the map unit, the codominant soils 25 to 50, the associated soils 5 to 35, and the rest is ignored. Doesn't show up in the name of the map unit. And the second step is reduce the number of qualifiers. So the first scale level is just the reference soil group, the second with the first applying principal qualifier, the third with the first 2 applying principal qualifiers, and the 4th scale level with the first 3 applying principal qualifiers. And if you are thinking that an important characteristic for your map unit is missing, then you have the possibilities, you have the right to add after the name of the reference soil group other qualifiers that may be added optionally, which may principal, not yet in the name, or may supplementary, and they may be added at any scale level, 1st, 2nd, 3rd, or 4th. Another progress, I think, is the introduction of the sub-qualifiers. Skeletic, for instance, is a qualifier, endo is a specifier, and endoskeletic is the sub-qualifier. We have sub-qualifiers with a given definition, and like proto-calcic, and we have sub-qualifiers constructed by the user. Some are related to depth requirements, others to other requirements. And we have, amongst these sub-qualifiers, optional, additional, and mandatory ones. The mandatory sub-qualifiers, this is a small number. All the others are optional, additional. That means it's your decision whether you use them or not. Other progresses of 2014, introduction of a new chapter, rules for naming soils and creating legends for soil maps. This chapter is very important and very helpful, but only if you read it. So it's just 9 pages. And on the reference soil group level, there was one change made. Albuluvial soils were deleted, ready soils introduced. Albuluvial soils had a so specific definition that they hardly existed. And of course, many definitions, I think, better worded. Okay, the demand of a new edition. Is there a demand from the community? Before 2014, based on the 2006 version, yes, there was a strong demand from the community, especially because the 2006 version was unsuitable for making maps. And before 2022, I do not really realize that this community doesn't request a new edition. The community seems to be more or less happy. Of course, some improvements can be made, some things maybe not so good, but generally the community seems to be happy. What about the inner WRB circle? So people like you. We made from 2014 to 2019 common excursions. And one of the insights is always we fight about what we see, which characteristics are present in soil. And if we agree, after agreement, classification goes fluent. So many field terms in the WRB criteria are nowhere precisely defined. Not in the FAO guidelines, which have been recommended to use, and not in the WRB itself. And if we do soil description according to the FAO guidelines, some field criteria are not provided at all. And some others are provided, but not the needed limit values. So you cannot really use them. So we have not really a field guide. And the second thing we experienced, we developed an automated classification. This was done by Einar Eberhard and myself, and the input data we used, input field data, are according to the German field guide, and the input lab data, of course, are general. We published that in 2019. It works quite well if we have complete data, but some criteria are almost impossible to automatize. And some criteria are so specific that they are normally not surveyed in the field. So if we look at the field descriptions, we don't find what we need. So they are not described in any field guide, neither FAO guidelines nor somewhere else. You must have in mind, okay, I will need some specific criteria here. You must know that in advance and then especially look for that, but you will never find it in your databases. So that's why we made the decision to develop a new field guide and give it as an annex to the WRB. Okay. This new field guide provides precise definitions of field characteristics and guarantees the survey of all the field characteristics needed for the WRB definitions. It provides something more, but not much more. So if you are interested in other things, you may need other guides. And it provides quantitative field data where required for WRB. And we have the advantage all in one book, the classification and the field description. So they are really related to each other. All in one book. That's how the book should look like. 7 chapters. The first is always the introduction. You may skip background and basics. The second is very important. You must read it, the rules for naming soils and creating legends for soil maps. Then third, as it was before, diagnostic horizons, properties and materials. 4, key to the reference soil groups with list of principal and supplementary qualifiers, definition of qualifiers. So no change in the sequence of chapters up to now, but now the codes for reference soil groups, qualifiers and specifiers were an annex up till now. They will be a chapter in the next WRB, because these codes are mandatory. If you use codes, you must use these ones. You're not obliged to use codes, but if so, use these ones. That's why they belong to the main text and then the references. And annexes, Annex 1, the field guide. This is new, replacing the FAO guidelines. Annex 2, summary of analytical procedures for soil characterization. This is as before, with some updates, of course. Annex 3, horizon and layer designations. This is also new, replacing also the FAO guidelines. 4 is a soil description sheet. This is also new, and it's an Excel file. So it's not printed. It's an Excel file, and I will explain it later. Annex 5, color symbols for reference soil group maps. Just a suggestion, because I got many questions, requests. Which colors should I use? Okay. Coincidence of main text and field guide. Example with texture. We have the problem different countries have different particle size classes. Especially there is no agreement where is the limit between sand and silt. WRB has it and ISO has it at 63 micrometers, United States and many other countries at 50 micrometers, Australia at 20 micrometers, Russia has a different system. So this is will cause many problems if we use words like silt and don't know according to which system we use it. Also, different countries have different texture classes. And therefore, also different countries have different guides for hand texturing. This is what we have in WB, in FAO, and in the United States. The United States designed it. This is England. You see, same names, but different areas in the triangle. And this is Australia. Again, different areas in the triangle. So if you do hand texturing, you will get different results. What you call silt loam, others may call clay loam, and so on. That's why we developed, based on especially 2 documents, one from the United States and one from England, our own flowchart for hand texturing, leading to the 12 texture classes we have. And this is a triangle where you see in 4 colors where the 4 qualifiers of WRB are found. Yeah, next example for this coincidence, the structure. For instance, Nitic Horizon 2015, criterion 3, has moderate to strong blocky structure, breaking into polyhedral or flat-edged or nut-shaped elements. Looking at the FAO guidelines, there is no polyhedral, no flat-edged, no nut-shaped structure. Nitic Horizon 2022, more or less the same wording, just I systematized and harmonized the wordings in all the diagnostics and in the field guide. So has moderate to strong blocky structure, breaking into polyhedral or flat-edged or nut-shaped second-level structure. And now we have this definition in our Annex 1. And you see here the pictures. So we designed pictures for all the structures together with explanations. Other example, redoxomorphic features. Look at the technical properties 2015. Mottles and or concretions and on nodules, the color of which is considered to be oxymorphic, that are, if soil aggregates are present, predominantly inside the aggregates and have moist amansal color U 2.5 units, at least 2.5 units redder than the surrounding material, and amansal color chroma at least 1 unit higher than the surrounding material. If we do soil survey with the FAO guidelines, what do we get? Mottling, we get color, abundance, class, size, contrast bound, and boundary. These are the tables 32 to 35, but no location, which is crucial for distinguishing Stucknick and Golake properties. And the concretions and nodules, they have no muzzle color. And what is also not questioned to have a decision or an idea whether it's oxymorphic or other. And then the key to the reference oil groups requires Stucknick properties in which the area of reductimorphic colors plus the area of oxymorphic colors is at least 50% of the layer's total area. But we have abundance classes. How to calculate a percentage from abundance classes. This is all changed now. Stucknick properties criterion 2 sounds familiar. The oxymorphic features are if soil aggregates are present predominantly inside the aggregates and have compared against the matrix color the following munsell colors: moist, a U at least 2.5 units redder, and a chroma at least 1 unit higher. So we get that from the Annex 1. Color, and for each color separately, you have to detect the substance. This is required for all oxymorphic features and for some reductimorphic features. The location for both all oxymorphic and reductimorphic features. The size only for oxymorphic features inside aggregates. The cementation only for oxymorphic features. And the abundance, that's now by percent. So oxymorphic and reductimorphic features, you can establish, observe the percent. And then we can decide for the key Stucknick properties in which the area of reductimorphic features plus the area of oxymorphic features is at least 1/3 weighted average. So with this combination of field guide and definitions in the main text, we can come to a conclusion. We took many of the definitions from the NRS field guide, field book. I had a meeting with Curtis Mongerer in 2019 when we discussed that, and he allowed me to do that. And many definitions are from there. Some literally, most are modified because the criteria of the field, they are not independent from the classification system. So you cannot copy them one by one, but they are very close. And of course, having common or at least similar, very similar definitions of field characteristics, this brings both systems closer together. So we talk about the same things. Annex 2. Now that's all I have in my presentation about Annex 1. Let's go to Annex 2. Summary of analytical procedures for soil characterization. We had that already in 2015, and it's a little bit updated. And what I especially added, pH alternatives if base saturation or relationships between cations are not available. So we can use the pH, but it's defined now which, and depending on what, depending, for instance, on organic matter. Annex 3 is horizon and layer designations. We have master symbols and suffixes to replace what is in the FAO guidelines. And now these are, of course, based on field characteristics, but also on lab characteristics, at least some of them. You need for your decision a lab characteristic. And of course, these are only rough descriptions, not intended to be definitions as in the diagnostics. That's not a second soil classification system. Okay, and here I put something in red. I know that some soil scientists do the following. They see a profile and say, oh, this is this soil, for instance, a stagnant soil. Then they give names, give symbols to the soil horizons to make sure that the soil is a stagnant soil. And after that, they describe the horizons to make sure that the characteristics fit the horizon designations. How can we prevent our colleagues, or I even must say that I'm not completely unguilty, not completely innocent when I describe a profile. What can we do to minimize this risk. My suggestion is place the horizon designations somewhere further behind in the book, after that require or force people to do the description first, to start with that. This also fits to what Curtis said in his interesting presentation. So we have to start with a morphology, and all other classification and genesis is detected, deduced based on what we have seen. We come into some problems. We used up the lowercase letters for suffixes. All the alphabet is already used up. Some even twice, with different meanings for organic and mineral horizons. That's not a problem, but we cannot have two different meanings for within the group of mineral horizons. So what can we do if we want to express new characteristics? Introduce Greek or Cyrillic characters? Or introduce special characters? We already have the at for the cryogenic alteration. So we can introduce, for instance, the paragraph for human transported material. Human transported material, artifacts we already have. This is the U. I heard from John that you suggest a caret. I don't like that, because I think a symbol should start at the baseline and not be somewhat further up. Maybe we can also agree on using a symbol for the human transported material. And I think we need a symbol for layers with volcanic classes. If it's a lowercase symbol, for instance, this and or whatever. We could also, for volcanic classes, we could also have the option to use a master capital letter, and then which we can then combine with other capital letters. So this is not so much the problem, but for human transported material, we really need a lowercase symbol. Okay, now about the profile description sheet. It's an Excel file with 2 parts, general data and layer descriptions, and 3 levels. So we provide macros. Complete, which is very large, of course, intermediate, and minimal. But we also invite you to create your individual Excel file and delete what you not need or maybe not want. I'm not really forced that you don't want something, but many things you really don't need. So desert features, if you are not in the desert, there is no need to have them in your Excel file. Or climate and ecozone, if your country lies just in one, you don't need that. You don't have to report it all the time. And whatever you are sure you really don't need. And it looks like that. This is the general data. Okay, I just criticized that letters are too small in some presentations. Here they are too small, but you get an impression what it is. And brown, the field guide provides a code. And green, you have to add a figure or a name. And the same thing for the layer descriptions. Okay, and this is the last annex, Annex 5, color symbols for reference soil groups. These are more or less the colors of the atlases of the Joint Research Center of the European Commission. Up till now, we have it in red, green, and blue, and maybe we can also get from the JRC the CYMK system. Okay, now let's go to the general rules. So one problem is about soil surface and mineral soil surface, because we use these terms in WRB and they are nowhere defined. Look at this picture. Which soil do we have? There is some organic layer at the topsoil, and this is a trunk, thicker than 40 centimeters. And, well, where the trunk is, there's a folic histosol, because it has an organic layer thicker than 40 centimeters. And the rest is a cambisol. That doesn't look well. Other problem. This is, in West Siberia, an ombric histosol. And we have dead sphagnum residues in contact with living sphagnum plants. You see them on the right-hand side. The topsoil, there are living sphagnum, and the dead sphagnum parts in this further down are still connected. Where is the soil surface? Also here, problem 3. This is a soil after litterfall. You see there is a rather thick organic layer at the top. And this is in late summer. There's almost nothing. Litter layer thickness varies with season. That's why we thought about a definition of soil surface and introduced a litter layer. A litter layer is a layer that contains more than 90% by volume recognizable plant tissue, like this trunk. And that plant material still connected in to living plants, for instance, that parts of sphagnum mosses, is not regarded to be part of litter layer, only just what is really lying on the surface. And now we can define the soil surface, 0 centimeters, is the surface of the soil after removing, if present, the litter layer, and if present, below a layer of living plants, just the living plants, not the dead parts connected to them. And then the mineral soil surface, that's not so complicated, is the upper limit of the uppermost mineral horizon. Are we, with that, in agreement with other systems? See soil taxonomy. Conventionally, the soil surface is considered to be the top boundary of the first layer that can support plant growth or root growth. This equals to, let me jump to B, for vegetated mantles, for vegetated mineral soil, the upper boundary of the first layer that can support root growth, and C, for organic mantles, the same as B, but excludes freshly fallen plant litter and includes litter that has compacted and begun to decompose. This is the OI horizon in the US system. So it excludes freshly fallen plant litter and includes litter that has compacted and begun to decompose. And allow me to have a look at the German system. We look at the Bodenoberfläche, BOF. This is the upper limit of the uppermost horizon, including freshly fallen plant litter, which will be called OL horizon in the revision of the German system. So now we have solutions. This is solution 1. This is the soil surface. The trunk is just a litter layer. And the whole soil is a combisol. Where is the soil surface here? Right below the green parts of sphagnum. And here, yes, it excludes the fresh fallen litter. So soil surface doesn't change with the seasons. So these are some general things. And now let's have a look at the reference soil groups and then some qualifiers. Reference soil group. I suggest a change in the sequence, planosols and stagnosols before nitisols and feral sols. This is suggested from Brazil, and I guess they have many experience with these soils. And I think it's very understandable. There is no suggestion for a new reference soil group, and there's a discussion. Should we abolish retisols? So in the moment, the discussion is almost equal weighted. Both sides are almost equally strong. Are the retisols ecologically important? I think yes, because the coarser textured parts are the preferential water flow, and most roots are found there, not in the clay or richer part where they could have more to eat. Are they genetically important? Not so much. Can they easily be recognized, especially over large areas? No, simply no. And alternative make the definition stronger. For instance, require a higher minimum thickness of the layer with retic properties. This is a discussion where I really don't see what will be the decision. We will wait. We have to wait. Now let's see at some diagnostics. We have some abolitions. The fulvic and melanic horizons. These are more or less the direct result of vegetation, grassland versus forest. And they are only foreseen for undersoils, but they don't provide a meaningful differentiation and could also occur in other reference soil groups. And they are based on the old idea that fulvic and humic acids exist, which is strongly questioned by the experts of organic matter. The other one to delete is the Jerick properties. This is an unsuitable combination of delta pH value, so delta pH 0 or even positive, and a very low cation exchange capacity. So we need three qualifiers: the POSIC for positive or 0 delta pH only, the VETIC for the very low CEC only, and the Jerick for a combination of both. Better have only two qualifiers: POSIC for the high delta pH, Jerick for the very low CEC, so we can delete the VETIC qualifiers and the Jerick properties. And now we have some news diagnostics in discussion. Here is the cohesive horizon, from Latin cohere, to stick together. This is a subsurface horizon with a massive structure or a weak soil aggregate structure. It's not cemented. Clay fraction is dominated by kaolinite, typical for old landscapes in the tropics with seasonal climate. And they are found in the national classification systems that have of countries with large areas in this ecozone. For instance, the Candosols in Australia. In South Africa, we have the apedal B horizon, and in Brazil, we have the Carata Coeso. This is, we can say, the counterpart of the Nitic horizon, which is strongly aggregated, and the cohesive almost not. And this, of course, has a significant negative impact on plant growth. Now, the Pan-Pike horizon. The question or the problem is starting with a Sombric horizon. What is a Sombric horizon? Is it a buried A horizon? Or is it the lower remnant of a formerly thicker topsoil A horizon? So developed under a climate that allows the development of thick A horizon. And then this climate changes, and the recent A horizon, the recent climate allows only the development of thin A horizon, and further down, the organic material starts to decompose. But of course, if it's even further down, decomposition is slow. So there are still remnants of an A horizon. Is this the Sombric horizon, or is it a buried horizon? And this is an experience of mine I have since a long time. If I send a message to the community and ask for the discussion, nothing happens. If I set up a definition, and this new diagnostic horizon appears in the WRB, then people start research projects about that, and then we can come to an answer. That's why I suggest to introduce the Pan-Pike horizon, from Quechua Pan-Pai to Berry, for a buried A horizon. So we started already in 2014, not derive everything from Latin and Greek, but also give the opportunity to other languages worldwide to be reflected in WRB. And here, Quechua, the language spoken by the descendants of the Inca Empire. And now we can clearly say, if we have the Pan-Pike horizon, we can add to the definition of Sombric horizon no lithic discontinuity at its upper limit. So now it's a different thing, and then the research will start to prove that it exists or that it does not. This is the Zitelic horizon. From Georgian Ziteli, which means red. Lateral accumulation of iron. So we have it's usually found on lower slopes or in these depressions, and we have stagnosols or planosols upslope, and in inclined positions, it moved the reduced iron from this stagnosols and planosol, moves down by lateral subsurface water flow, and further down, the reduced iron gets in contact with oxygen, is oxidized and accumulates in a subsurface horizon, but close to the surface. So it is rich in oxide extractable iron, which gives the Zitelic horizon a reddish color. we must find out a bit which color really it has. And if fine textured, a low bulk density. So I realized now that this is not the case and cannot be the case on coarser textured soils. So we will have an adequate, we will change this into an adequate definition of the zetetic horizon. Here, the issue with anthropogenic horizons. The current definitions make many of them mutually exclusive, which does not reflect the reality. See this example. From 0 to 20 centimeters, a horizon meets the criteria of the Hortic horizon. And from 20 to 50, the criteria of the Praetic horizon. Then it's not an anthrosol. Because the Praetic horizon is worded in such a way that it's exclusive to the Hortic horizon. And the anthrosol needs an anthropogenic horizon of at least 50 centimeters thickness. So this beautiful anthrosol will not key out as an anthrosol. Therefore, solution, take out this criteria from the Praetic horizon that makes it mutually exclusive from the Hortic. And now we have the Hortic horizon from 0 to 20 centimeters and the Praetic horizon from 0 to 50 centimeters, 20 centimeters coinciding with Hortic, and then this soil is an anthrosol. The issue of the petro horizons. Petrocalcic, petroduric, petrogypsic, petroplintic. So we had the discussion about the petrogypsic, you remember, in the excursion. All horizons need to be continuously cemented. They may have fractures. This is also part of the definition. But besides these fractures, they are continuously cemented. And to test that, look at the field guide, Annex 1. Specimens do not completely disintegrate in the water. And the cementation class of everyone is different. Petrogypsic only needs at least extremely weakly cemented, then petroduric weakly cemented, petrocalcic moderately, and petroplintic strongly, besides many other criteria every horizon has. So with these clear definitions in the field guide, we can easily detect all these petro horizons. And I propose a new diagnostic horizon. In the beginning, I called it petroclaic, but I got the solution that we could, the input that we also could call it limonitic, maybe a bit more adequate because it is cemented, but not necessarily continuously, and therefore it may be wise not to call it petro something. It develops in layers with clayic properties and oxymorphic features, and cementation class for those parts that are cemented, at least moderately. Yeah, so the definitions CNRSS, NRCS Fieldbook, and WRB Annex 1, the same. Then new diagnostic material, we already discussed it yesterday when Sergey, oh, he left, Sergey pointed out that the Czernik horizon should not be a remnant of a former organic layer. The mulmic material from German Mulm, powdery detritus, mineral material derived from organic material. So if water-saturated organic material is drained, mostly artificially, a fast decomposition starts. While the amount of mineral components remains constant, where could they go? The amount of organic matter decreases by decomposition, and the organic matter content eventually falls below 20%, and then by definition, we have a mineral material. And this is useful as such. We can add the mulmic qualifier, but also the mulmic material can be used in many definitions. The histic qualifier, that it's still histic if we have waterlogged organic material, but the top is by drainage dried out and now no more organic. Or also for the mineralic qualifier, which we have in histosols when we have a sequence of organic and mineral layers in the histosols. And now the question raised yesterday, should we add to the criteria of the Czernik horizon not consisting of mulmic material? I think we should not add it to the molic horizon, but to the Czernik maybe. Yeah, and also new diagnostic material, organotechnic material, mainly to avoid the following problem. Organic material has to have at least 20% soil organic carbon. And soil organic carbon is a diagnostic material defined as organic carbon that does not meet the criteria of artifacts. This is very fine. It helps us easily in all the definitions, but up till now, all other materials are mineral material, even if they are 100% consisting of organic artifacts. We call them mineral material. And this doesn't sound good. That's why I have the idea to introduce the organotechnic material that has less than 20% soil organic carbon. So if it has more, then it's organic material, of course. Less, but it has, and this could go by volume, at least 35% artifacts that contain at least 20% organic carbon. With that, we can go to this organic technical material, organotechnic material, and avoid that a thing that is organic is called mineral. One sheet about the qualifiers, some new qualifiers, some others deleted. I checked all qualifiers. That was really not easy. Whether the depth criteria should be related to the soil surface or to the mineral soil surface. For some it's easy, for others not. Remaining problem, hyperskeletic must be related to the soil surface and skeletic to the mineral soil surface. Maybe we should replace the word hyperskeletic by something else. And another problem that remained, the calcic horizon. In mineral material, it must be related to the mineral soil surface. This is the calcic qualifier. But in organic material, for instance, in histosols, it must be related to the soil surface. We can have these accumulations of secondary carbonates in the organic material. And looking for a word, I looked up in the dictionary what it means is Polish for lime, and I suggest the Wapnick qualifier. If the Polish native speakers think that this doesn't sound good, we can choose another word. And we have up to now the acric, lixic, alic, and luvic qualifiers. And it may happen that we clearly see an Arctic horizon, but we don't know the cation exchange capacity and don't know the base saturation, and then we have to guess what it is. I don't like that. We can delete them, these four, and replace them by the Arctic qualifier. If we know the low CEC, we can anyway add the sideretic qualifier. This is a CEC below 24 cm per kilogram clay, like in the lixic and acric. And if we know the low base, the base status, we can indicate that with the district and the Utic qualifier. Nothing is lost. It's just a bit separated. What is our time frame? There's a DWB board with 15 soil scientists. Some are here in the room. We have several video meetings in the next weeks, and then we have an in-person meeting in Germany from May 31 to June 4 at my university. June 5, we all fly to Iceland. WB this time will be an electronic publication only, but with an ESBN bought by the IUSS, and we will present it at the World Congress of Soil Science in Glasgow, July 31 to August 4. And now about the translations. I have up till now volunteers for translation into French, into Italian, and into Spanish. They are here. The one group for Spanish translation is from the INEGI, and the other is Carmen, not here. Okay. Yes, thank you. And the most problematic of these three, of course, is Spanish. French, what is French? This is decided in France. What is Italian is decided in Italy. What is Spanish is decided in Spain, Mexico, Guatemala, El Salvador, Nicaragua, Argentina, and so on. So this is an important issue. American and European, so provide a draft and then sit together to decide on the keywords or use the same keywords as we had in 2015, that every Spanish-speaking nation can agree on that document. I'm sure there will be some translations in other languages, like in WB 2014 Polish, were the first ones. Yeah, and the last slide is just personal, because Wolfgang Zech, myself, and Gerd Hintermeyer-Erhardt made this book. You see the cover is already ready, and we think that it might be available in May or June. The soil is a plinter soil, as you see. And with this picture, thank you very much for your attention.
Okay, so we heard a lot of details, but I would like to ask you first to ask the general questions, if you have any. Where are the great soil scientists to have general questions? There's so many details. Huh? If we start to ask if a calcic horizon can occur in a peaty soil, it is possible. And I'm not sure if this would be related to the top of a mineral soil. It's not existing. Huh?
Related?
It's not existing a calcic horizon. There's no mineral surface existing in a peat soil.
No mineral surface existing.
So there is coming up the general question. Curtis, come along.
I think this is a general question, but the soil surface versus the mineral soil surface. The soil surface, one forest fire and it's gone. One fire and that O horizon is gone. So it can be very ephemeral. It can be very dynamic. It can disappear rapidly. Is that a concern?
Yes, this is a concern. For the mineral soil surface, of course, will not change. The soil surface, including the organic layers, will change, will disappear, yes. Even if we exclude the litter layer, the others also can disappear. Do you have a suggestion for the solution?
At one time, in the UF system, the top of the soil was the top of the O horizon, and it would be the horizons would be measured down vertically. But because of forest fires and because the O horizon can be so, it can disappear so rapidly, it was moved down. And I think on our field trip, our field excursion, if you noticed, all of the tapes began at the mineral soil surface, and the organic was additional above that.
Counted upwards, yes.
Yeah. So that was why I was wondering if it is a concern.
Yeah. Okay, thank you.
Okay, now over the really, you have a general question? Go ahead. No, let's start with the detail. Okay.
It is partly general, but it is, I think, also very detailed question, and I think it is never-ending discussion, as Peter said, and also Curtis. The distinction where is soil surface is absolutely crucial for classification of various soils. When we have, for example, continuous transition between litter, transformed litter, something what is hydrous, like peat litter, and to peat, and where is which thickness should be calculated that's organic, how cold is organic. But the other problem for me is also important. That classification of organic horizons and naming of or letters, designations for organic horizons are already exactly the same for forest or meadow litters and for pits, for example, and the materials developed from pits. But in my opinion, it is not exactly the same concept and not exactly the same criteria. As you showed us, for example, classification of sub-horizons in Germany, OL, OF, OH, in my opinion, it is not exactly the same what we have for pits or and so on. And this is the reason for many troubles, in my opinion. Disagreements between WRB and local classifications. Additional problem is that in many countries also the classification of litters are different. Yes, the letters are also different, use and different, how to say, definitions. As recently, for example, proposed by Zanella and other, it is completely a different story. Yes, but for me, the zero is where zero is very important. And as you told, we should probably exclude the fresh truffle because it is unstable, and we agree to this. But there is the detailed question to the limits. Yes, because if we put of 90% of preserved visible plant tissues, what's that? Is it all F or L? What's that? And or E or A, and people will have large troubles. So I agree with general idea to reject this fresh truffle, but better is the definition, the German definition, than 90%. So better is German, that we should just exclude OL or LL in some classifications, fresh truffle, without this 90%. Because 90%, what is 90% of visible tissues?
Okay, so first of all, the German OL is defined by having more than 90% visible plant tissue. This is exactly the same, and the 90% value is also in soil taxonomy. And I think if we have other limits like 1/2/3 and 1/6, and if you are able to determine 1/6 and 2/3, you're also able to determine 90%. We have the different capital letters, O and H. This is different to soil taxonomy that has only O. And with that, we make this differentiation. The other thing is, should we use different lowercase letters with different limit values? This has, of course, the advantage that we can do it more specifically, but it has the disadvantage that we made the system more complicated. People have to think in more, and I really think we have to be strong and do that only if we really are convinced that it's absolutely needed.
May I add, it's not so easy, Cesare, because we had this example where the litter disappears in a few months. I can show you soils where we have 7 litter layers. So the litter stays 7 years in this until is degraded to O horizon. Yeah. So in this case, you will always describe a litter layer.
I wanted just only to say that 90% of preserved visible plant tissues do not represent fresh truffle, because in many OF horizons, we still have more than 90% of preserved. Maybe there are cutted, there are smaller, partly transformed, but still we have 95, 98% of preserved, recognizable plant tissues. Yes, so this is my suggestion, that 90% do not plus the border between OL and OF, but in many liters, somewhere in OF horizon. And this percentage will complicate us, not help, but in many situations may complicate establishing zero. Yeah.
So let me ask if I got it right. Your suggestion is leave out the percentage and just say it's fresh. Like both soil taxonomy and German have these 90% value, and we use it since decades and didn't find the problem. But okay, now I got what you want, understood what you want.
Okay, more questions, please. Ben, is this a question?
A general question, yeah. A comment on feedback I get is difficulty navigating around the text and finding definitions. So I'm just wondering, I think the diagnostic horizons, properties and materials should be taken out of their individual sections and just placed into an alphabetic sequence as per a glossary to cover, because it's navigating between properties, materials and horizons is complicated. I'm just wondering whether anyone else feels the same way. Is that an...
But this is as it is. We have the chapter on the diagnostics, and then we have the diagnostic horizons in alphabetical order.
Yeah, I know. I'm saying that, but that's confusing because sometimes you're flicking between horizons and materials, and like it would be more usable, maybe more user-friendly if everything was in an alphabetical sequence, regardless of whether it was a horizon, a material, or a property.
Don't know.
Okay. John, okay.
Peter, on the, I don't recall the name of the new horizon, but the materials where it developed churnic properties, but began as maybe a wetland soil. How would a field soil scientist be able to determine that it originated as such a soil?
Yes, so it's difficult. That's why part of the criterion is that you have to know that it was wetland before. I think it's hardly possible to do it when you are, when somebody guides you with eyes closed, and then you must tell whether this is derived from wetland or not. In some cases, you will be able to see it, in others, maybe not. So I added this to the criterion that you must know that. Besides the other criteria, how to recognize how much organic matter, which structure, and so on.
In the moment, I don't see any other questions. So that's time to come to the conclusion. At first, thank you, Pedro, and thank all you for participation and discussion. I think we have had an important lecture now because we hope that we will work with WRB in the future, and we need a classification which really describes almost everything which occurs in soils. But at the same time, it should be simple as possible, and all the definitions should not overlap, so should have clear boundaries, and they should be easily applied, and we should not have too many mistakes in it in the future. So this is still some work to be done, I think, but we are on the right way. That is my impression of today. So let us go on and also help Pedro to make a very good WRB 2022, and then hand over to Cesare to continue make a good work and also help the people working with WRB. So thank you for this day, and please come back tomorrow morning. We continue.
Sorry, some advices. The session for tomorrow is in the. The session for tomorrow is not here. It's at the Geosciences Center. It's nearby here. It's the yellow building. And also, we are going to take the picture of the Congress right now at the exit of this building. So see you there. Thank you.